Hello everyone, am I audible?
Yes, sir.
Yes, sir, you are
Yeah,
audible.
sorry for I just joined with looking there are 33 participants only. Okay, so let's wait one more minute. People will increase. This is Maths 2 session. I'm Subham. Today is solve with assignment session.
You are not audible, sir.
Am I audible right now?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So let me share my screen so people will join.
Sir, can you briefly explain what is the rank of a matrix?
Okay. Yeah, we will discuss. We will discuss this. I hope, like not all, but many of you seen attended the Subhajit session. He continuously taken 3 sessions
Yes, sir. Yes, sir. I
on
attended all the
week
sessions.
week 3 and week 4, and that's the really like you will think as a lecture
Yes, sir.
session. I hope like like if no one watched that, like I mean the scenes meant to say, if anybody didn't watch that, please watch those sessions. It's really good and lots of appreciation are we are
Yes, sir.
looking.
Those sessions were really good.
And for that, like what is vector space, what is linearly independent dependent, and what is basis, what is span, all things are taken or introduced in the sense uh, cleared
Sir,
out.
in the meantime, can I discuss one activity question doubt? It is regarding some basic concepts, sir.
Okay, so what?
Sir, activity 4.1, question number 10.
Okay, question number 1.
Question number 10, sir. 10th question.
Okay.
In the first option, sir,
Mhm.
let us take the option M to be 1. Right, sir? It satisfies the equation y equal to mx.
Mhm.
Then
x is equal to 1.
no, sir, m is equal to 1.
Sorry, m is equal to 1. Okay.
Let the slope be 1.
Mhm.
Sir, first option is given to be correct. How is it linearly independent 1, 1 and 1, 1? These are multiples of each other.
Mhm.
These cannot be independent.
Okay. So 1
It is
m.
nowhere mentioned that m is not equal to 1.
No. So yeah, so that's the confusion here for you. Like not asking for like m is or 1 is independent. These two vector 1m. This is a vector. 1m is a vector of R2, and 1 by m and 1 is another vector of R2, or that V subset of
Yes, sir.
V subset of R2.
We,
So is
sir,
these two vectors are linearly independent or not? You have to check this.
sir, they are in the same set, right? This is the one set in which there are two elements, 1m, 1 by m, 1. These are the two elements. Sir, suppose we take m equal to 1.
M equal to 1, okay.
Then they are not linearly independent.
M equal to 1, then they are not linearly independent. Oh, okay. Oh, regarding that you are saying.
Yes, these are in the same set, and this set belongs to V. And no violation of any condition.
So okay, what is that then? The options. Okay,
First
it's
option,
a spanning set for V. So is a linearly okay. So
when they are
this
not,
option is not true. Okay, I thought maybe I thought this option is true. So this option is not true, huh?
Okay, go to the second option. How come it is a spanning set when they are not linearly independent?
So again that option is not true or is given to be okay. So okay, sorry. So this option is given to be true. Okay.
Yes, sir. Some contradiction is there.
So what it mean by like what mean by spanning?
So spanning set is the minimal set which spans the vector V. right? And these two elements have to be
No. So
independent.
that's the confusion. Not minimal.
Not minimal.
Only
yeah,
just
yeah.
set can span that whole V. That's all.
Yes, sir.
That is not a minimal. So again,
Yes, sir.
see,
I am somewhat confused, sir. Can you clear my confusion, please?
So you are saying that's why I asked the definition of spanning. Spanning is not saying anything like minimal, maximal, linearly, or minimal.
Sir, what I understood
They cannot
is
be bases. They can be spanning set.
yes, sir. He is confused between the spanning set and the basis, I think.
Okay. Oh, so is that?
Yes, sir. Might be. If you can
Yeah,
clearly.
because he's saying minimal. That's why I'm
Okay.
saying that.
So first, see the definition of spanning set. Spanning set is nothing but a set which can generate which can suppose there are two vector. This is subset of R2. So this is a subset of R2, let's say, and means two vector, saying to be two with there are two containing two vector and linearly independent. Okay.
Right, sir.
Consider another set A, B, and C. Okay. This is again a subset of R2, contains three vector. So these two vectors, I am saying these two vectors are linearly independent. So if you take this spanning set of this set, yeah, span of this set, what will be? It will generate whole R2.
Yes, sir.
And if you take a span of this set, it will also generate whole R2. But the
Right.
differences is this is not linearly independent.
Yes, sir.
The reason is it contains this vector, which see this generates the whole R2. It means what? This vector can be written as a linear combination of these two.
Yes, sir. Right.
So that means these three vectors are not linearly independent. They are linearly dependent. And this set is, see, basis means minimal linearly independent,
Okay, sir.
or what is that definition?
Maximal.
Sir, minimal spanning set or maximal.
Minimal spanning set and
Maximal-
containing the maximal linearly independent.
Yes.
So basis.
Okay, sir. Now I get the difference between a spanning set and a basis.
Getting the basis is different and span is different. Span can generate whole vector as well, no matter. But the thing is, if those vectors are linearly independent, then we will say that set is
the basis.
Otherwise, that set is not basis. That's it.
Sir, basis is a subset of the spanning set.
Basis is a subset of spanning. Yeah, you can say basis is a subset of spanning.
So can a point be a subspace?
No. In regarding to R2 or R3, you are saying.
Regarding R2, so can you write? So suppose I have a vector V1, which is x0, and I have a vector V2 which is 0y.
Just one x0 and 0. Sorry, what is that? Vector is
X comma 0.
x. Okay, just one minute, why it's not erasing. X comma 0. This is a vector. Okay, another vector.
0y.
0y. Okay.
Now both of them are in R2.
Okay, yeah, both are element of R2 or vectors of R2 of the vector space.
Yeah. So is the intersection of both part of R2, because intersection of both will only be origin, right?
No. So how do you think that? See, these two are vectors. So how you will take intersection of these two vectors? Intersection can be possible of a set, right? So you have to make a set.
Okay, yeah.
Then you will take intersection.
Yeah, so if I take this intersection of these two sets, will it only be origin or something else?
So what will be the intersection as the set theory? What will be the intersection of these two vectors? I think that x is not equal to 0 and y not equal to 0 in such case.
Okay.
So what will be intersection in that case? phi will be. There is no vector. There is
So
no
is phi the subspace?
phi is
Empty set.
yeah, actually phi is saying to be like 0 subspace. Phi is subspace. Just 1 minute.
It is a question in activity 4.2. That's why I got confused.
Okay. Where is that?
In the activity 4.2. Go down. Yeah, this one.
Mhm.
Question number 4.
So, okay, see, now here is written in the set form. Okay, intersection is a subspace of R2.
So
You
it is
need,
given that intersection is subspace of R2.
so the option is true, right?
Yeah.
So actually, see,
So intersection would be only the 0, 0 vector, right?
no, not okay. For here, for
In this
for
case,
this question.
it
in
will
this
be 0,
case,
0.
in this case, intersection will be 0, 0.
Correct.
So in this case, the subspace is happening because
No,
when you take,
sir. I think, sir. Can I speak?
yeah,
Yeah. So I think that if V1 and V2 is any subspace, then intersection always will be a subspace of R2, whatever dimension it is given. Because, sir, if it is given intersection, then it will be the common element of both of the subspace, right?
yes.
Vector space, right?
Yeah,
So-
but my confusion is that intersection over here is just a point.
Sir, it doesn't matter.
Point is
It
a
doesn't matter.
subspace.
Look. Whether it doesn't matter whether it is a point, whether it is a set of point or whatever, because V1 and V2 is a vector space, and the intersection will also be the common element of both of the vector space. Then it has to satisfy the condition of subspace, right?
So no, his confusion is still is that point is can be a vector space or not. So see, here the case is point is 0, 0.
Yeah.
If suppose the point is, suppose you are taking the intersection and you are getting the intersection is at 0, 1.
0,1.
So in that case, this is not a subspace. This is not a subspace. It will be in the set form.
Sir, I don't know about this thing, but I know one thing that if we will take intersection of two
subspace,
vector
yeah,
space, then it has to satisfy the condition of
It
subspace.
will be a subspace of it.
Yeah,
Suppose you are taking a subspaces like that, not subspaces. You are taking intersection
space.
of two
Vector
sets. And in that case, you are getting a single vector which is apart from 0, like not a zero vector, different from 0 vector. In such case, that not be a subspace.
Yeah, then you have to mention that it is a simple set. It is not a vector
You have to
space.
mention that it will be a simple set.
Yeah. I'm just talking regarding this question that if it is given two vector space, then intersection always will satisfy the condition of subspace. Right?
Correct.
Yeah.
Correct.
Hello, sir.
Is it clear? No?
Hello, sir.
Yeah, so I will. So can I reiterate once? So just because okay, so 0, 0 for the subspace, it is following all the three conditions. All the point that it has a 0 vector closed under addition and closed under multiplication. That's why it is a subspace, right?
Yes.
0, 1 will not follow that. That's why it is not a subspace.
0 is not following. That's because 0, if you are taking that set, in that set, 0 vector is not there. And for you know that for checking a subspace, 0 vector should be in that. Then it will be a subspace.
Okay. Got it.
Yeah, someone is asking.
Can I say
Sir,
something?
for R2,
Hmm.
there are three subspaces like 0, 0 and a line passing through origin and R2 itself. So in this question, 0, 0 is, I think, intersection point of V1 and V2. So it is also a subspace.
It is a subspace, yes.
Yeah, that's why I am.
Okay. Yeah, some girls is asking. Okay. You can continue also.
Sir, can I say something?
Yeah. Sorry. Okay.
Sir, can you please solve some question related to vector space, basis, dimension, rank, this type regarding this type of concept?
Yeah. So yeah, let me continue with my slide which I have prepared. So in that I have collected span and all the basis, dimension, rank also. So let's continue with that. Then it will be more. In that we will discuss the concept also and discuss the solution of that question also. I am looking a
Hello, sir.
3% raised hand. So let's see that. Yeah, let me see that.
Sir.
Want to ask Ajay? Do you want to ask something?
Yes, I have a doubt. So can I ask
Yeah, sure.
now or later?
Yeah, you can ask now itself.
Activity 4.1, activity 1 for question number 4.
Activity
4.1.
4.1, question number 4. 4?
Yes.
Yeah, 4 is just now we are discussing
Yes.
that. 4, okay. This is okay. This one.
Yes. Sir, how to find the value of n? So I put the answer n equals to 1, but got the wrong answer.
Yeah, so yeah, I will tackle this question with my slide which I have done. Okay. So in
Okay,
that
sir.
I have a question, same question, same in the sense similar question. So let
Question
me
number
see.
9.
In this question, does it mean that these two are independent?
Yeah, you have to check, right? You have to check is that happening or not, because asking span is equal to Rn. So this is the given condition. If such case is happening, what it mean that
we have to check whether they are linearly dependent or independent.
Or
If they are independent, then these both have to be there to span all of the Rn, right? And then the basis formed is 2. Therefore, the value of n is 2.
Yeah. So yeah, we will discuss. I have this. I have question. Okay. Question number 9. Okay.
Yes.
What is doubt here?
Yes. In this question, okay. So question number option number 4.
Spanning is
In this,
this is a spanning
yes.
set of V or not?
Yes.
Okay.
Check the condition whether it is satisfied or
So
not. First of all,
just use the definition. Just use the definition of spanning. What is the definition of spanning?
Linear combinations.
X is equal to y minus z.
Single vector is always
X is equal
linearly
to
independent.
y. That is condition. X is equal to y minus
Satisfies
z.
the definition.
X is equal to y minus z.
So let me tell you that what is the first definition of spanning is. Spanning says if you have a set, it will if you are saying this set is spanning set of V, that means if you take the linear combination of vectors of these vectors, it means alpha A plus linear combination means just write the, like, let's say I'm writing alpha A plus beta B plus gamma C, where alpha, beta, and gamma are any real number. Mean to say, alpha, beta are any. Just 1 minute. Just 1 minute.
Hello. No audio.
No, sir is coming back.
Hello. Can hear you.
Everybody is audible. He has, I think somebody interrupted him in between. Please wait.
Sir, I'm not able to hear anything.
Nobody is speaking. That is why I think Sar's wife. I think Sar's wife gave him an important task.
Yeah.
He has to listen to that before everything else.
Okay.
Just kidding, man. Don't take me seriously.
Well, I should take you serious. Sir might.
Is the topic related to vector space ends in week 4 or it will continue up to the total term? I don't know.
Topics will build up on that particular week, vector space and vector span. But yeah, you will see vector space topics.
But in last session, sir told, I'm not sure which sir, but one of the sirs told that we have to understand vector spaces clearly because it will continue through 8 weeks.
Yeah.
So, bad news, vector spaces throughout.
Sorry, everyone.
Sorry.
No, it's
Okay, so yeah, we will continue with the spanning. So spanning set is a take the like we have a vector. Let's say this is a vector space B, and these are the vectors in a set. So this set called a spanning set of V. If you take linear combination means linear combination of, let's say, like you have a vector 1 0 and 2 1. So linear combination of these two vectors means what? Let's say 5 1 0 plus 2 2 1 or 2 2 comma 1. So this is a linear combination of these two vectors. Similarly, you can change the number alpha, like here you can say alpha and beta, change the number. These are the possible linear combination, all alpha.
Or when we say linear combination, can there be a negative sign in between?
Yeah, it can be negative. These are the real number, right? So beta means you can take a negative real number, so it will change the sign. That means.
So then what is A1 V1 plus A2 V2?
A1 V1. A1. Oh, where is A1 V1?
That is linear combination. A1
V1 plus
linear combination.
So see, these are the vectors. Alpha. Let's say this is V1, V2. If you have a problem with the ABC, let's say V1, V2, V3. V3 are vectors. So linear combination is alpha time V1 plus beta time V2 plus gamma time V3, where alpha, beta, gamma are real number. Like here, I am taking two vectors here. You can take
linear combination, or only these two vectors are linear combination, right?
So, for example, I am taking two vector here. You can take three vectors. Let's say there is another vector. Let's say 1 3. This is a vector. So linear combination of these three vectors is take any these. Let's say alpha is equal to 5, beta is equal to 2, gamma is equal to, let's say again minus 1 and 1 3. So this is a linear combination of these three vectors. Similarly, if you change alpha, beta, and gamma, you will get many more linear combination of these three vectors. So the question is, if these three vectors you are taking this linear combination, and it will give, see, it will give a vector, right? Here it will be give a vector. This will give a vector. So if you have V, so is that all possible? Like whatever you are, similarly you are taking linear combination. So all vector of V can be generated by these linear combination. If such thing is happening, then you will say this set. If you are to make a set of using these three vectors, this set is called a spanning set of that V. Getting? No?
Sir, sir, what is the meaning of linear combination? Suppose linear combination of the vector 1 0 1 1 is equal to something. Then can we say that that point lies on vector spaces which have been formed by spanning 1 0 and 1 1? What is the meaning of linear combination here, sir?
Yeah, that's why I'm saying linear combination which you are taking. See, you have three vector. You are taking linear combination of, let's say, multiply 5 with the vector first 0. Similarly, 2 times 2 1. I'm multiplying gamma with which is I'm taking minus 1.
And suppose we get another point. Like
this is a linear combination of these three vectors. Similarly, if you change a 5 with different number, 2 with different number, you will get another linear combination. This is called linear combination.
So, sir, what is the geometrical meaning of this linear combination, sir?
Geometrical meaning of this linear combination.
Yeah. What should we interpret these algebraical sum in terms of geometrical concepts, sir?
I think, sir, that will lie on that plane.
Yeah, that's fine.
So here is the in R2. So suppose here is a vector, let's say 1 0, 2 1 is somewhere here. So linear combination of, if you will take linear combination of these two vector. So this is, let's say 1 0. Let's say this is 2, 1. So I'm taking a linear combination of only these two. So
Yeah.
whatever the vector, let's say what will be after what you will get after this multiplication or whatever the operation you will do. What is that answer? It will be
It will
7
be 7
and 2.
2.
So where it will be 7 2, it will be here somewhere.
Okay. So
you are looking what is happening.
So it would be 9 2.
Okay. Sorry, 9 2.
Maybe.
Okay. So it will be 9 2. Let's say this. So linear combination, you are taking these two vectors and somewhere you are getting a vector. So geometrically you are looking what is happening. Okay, this is happening. Okay, you have this vector, and you are taking some linear combination. You will get a here vector. If you change 5 with 7, so you will get a vector here somewhere.
Another vector. Yes.
Similarly, you will get somewhere. If you change 7 or 2, it will get similarly. You will get vectors of like this. So suppose this happening like this. Suppose all vectors in R2, whatever the vectors in R2, all vectors are generated by these two only. Suppose it is happening. Suppose you have these two vector and you are taking a similarly linear combination and it's generate all vectors of R2. So in such case, these two vectors are called, means this set now form the set of this, means you are collect these two vectors in a set. So this set is called spanning set of R2. Clear? Because it is generating the
so,
whole.
Sir, how can we check? Okay. So, sir, how can we check? Like suppose question 1 2 is a spanning element
is
of
spanning set or not?
Of 1 0.
Yeah. So the thing is, how you will check is this set is spanning set of R2 or not. So let's take a vector from R2. Let's take a general vector. Let's say x and y. I'm taking a general vector. Okay. So my condition is this vector is can be means generated by these two or not. So what it means that let's say alpha time 1 0 plus beta time 2 1 is equal to xy. Means suppose so you suppose you have taken that, okay, let's say these two are generated this vector. This is a general vector. So let's say alpha time this and beta time this is equal to xy. Till here clear? Till here is it clear?
Yes, sir.
Okay.
Yes, sir.
Yes,
now
sir.
what is that? Now let's solve this equation. What it will be? This is alpha plus beta comma and beta is equal to xy. Okay. Now if you compare it, what you will get? It will be alpha plus beta is equal to yes.
Alpha plus 2 beta.
Alpha plus 2 beta. Okay. This is 2 beta. Okay. Now
not that.
Okay.
X coordinate alpha plus 2 beta.
X coordinate.
This here, I think. Yeah.
Yes.
This is 2 beta. Now you have beta is equal to y. Let's find the value of alpha also. So what is alpha? Alpha is equal to x minus 2 beta. Beta means 2y. Clear? So what it mean? What it says? What
Hello, sir.
Hello.
Sir,
Yeah.
sir, in your equation, you write alpha 1 comma 0 plus beta 2 comma 1 equal to xy.
Xy is any vector of R2.
Yes. Then 1 0 2 1 is the linear combination or the total equation alpha 1 0 beta 2 1 equal to xy is the linear combination.
This is a linear combination. Like if you suppose this is a vector of R2 and you are saying this is a spanning
1 0
set
and
of
2
R2.
1 are the vector. 1 0 and 2 1 are the vector.
I think 1 0 and 2 1 are the spanning set of that particular vector, and not. I mean, if you add some alpha and beta to it, then you get the linear combination. But the vectors in this itself are the spanning sets.
Spanning set also include x comma y. No.
That's why checking here.
No, we are checking.
Is
Sir, am I right?
See, we are checking here is that these two vectors are this set, means which contain these two vectors is a spanning set or not. You have taken a vector from R2, like I am, what is that? Same, let's back to here. Okay, let's say this is somewhere xy. Okay, this is somewhere xy. This is the way to check is that these two vectors generate or span whole R2 or not. So let's say somewhere is somebody says I am saying these two vector like this set is a spanning set. So what it means that linear combination of these two generate xy. That's the mean, right? So I am doing a, let's say alpha time 1 0 and beta time 2 1 is equal to xy. This is the mean as linear combination means spanning means. I'm not doing any different as this definition is saying, only that way I'm going. Says okay, linear combination of xy. I just wrote linear combination of these two vectors and assume that okay, it generate xy. I made a equation and I went like this. Okay, I solved this equation and I found alpha and beta in terms of x and y. Okay, what it means that what it says here?
It says that sir, linear combination are possible.
Linear combination is possible. What it means? Let's say like here we took x y. So let's say x is equal to 1 and y is equal to 5. Let's take. So you have a vector means 1 5. So is 1 5 can be generated with these two? So yeah, you have an answer. What is answer? X is alpha is equal to 1. Here x is equal to 1 and y is equal to 2 into 5. Beta is equal to y, so means 5. So it means alpha is equal to -9, I think, and beta is equal to 5. So it means if you take here -910, okay, plus 521, it will give 15, right?
Yes,
Similarly, if you take any vector, if you change x, y, and you will get it,
Hello, sir.
you will get the different alpha beta. That means says okay, this is the this says that yeah, okay, these two generates whole R2 means this set is spanning set of R2.
Hello, sir. When we take two vectors from R2, that will be a linear combination of any other vectors. That will be happen.
What you are saying? Can you repeat it?
When you take two vectors from R2, that will always give a linear combination.
Not necessary. Not necessary. Not necessary. Not necessary.
Okay, sir. Can you give me one example?
You can take like 1 1 and 2 2, and you can check again the same way as you are doing.
So that is a one is a multiple of others.
Yeah, because of one vector is a multiple of scalar multiple of another vector.
Sir, suppose one summation. Suppose we write it in a write these the vectors in the set as column vectors of a matrix and solve for the linear equation. Is that method okay for checking if we have a solution?
Yeah, actually we are getting the same type, right? We are getting an equation which is a system of linear equation.
Yes, sir.
So actually we are solving the system of linear equation. You can change, yeah, you can go with that.
Sir, please can you write it once and just explain a little bit?
Yeah, you can do here. Okay, that is, you see, this is a simple equation. If you have a bigger equation like in 3 vectors, if suppose this is happening, suppose 1 1 0 and 2 1 2 something. So in that case, it will form a system of linear equation in 3, which contain 3 equation in 3 variables. So you can solve that and you will get answer. So that's the like this is the same process you can do like that will be.
So for example, if we have 1 1 and 2 2 as the two vectors, so we can't say that they can form a linear combination.
No, they will form.
But they will not be independent.
They are not independent. They will not. This
set
is
form
not
basis,
spanning
right?
of
They will
R2.
just remain spam.
See, this will not span whole R2. this will generate some particular subset of R2. It will not generate whole R2. Means spanning set of this containing
Sir,
this vector is
you
not
can
R2.
Sir, why not? I mean, it could form the entire R2. Why not?
So check as here
Yes.
we are doing. Same here as
I
here.
Both the
give you
points are in
One,
the
I give
two,
an
same line.
example.
let's
So
take
The second vector is a multiple of first one. They are dependent. That's why it will not generate entire.
If you are
R2. These have to
confusion
be
with
independent
that,
in R2.
if you are confusion with that, still let's say again, okay, assuming, okay, let's say I am taking a vector again, general vector xy, okay. So let's check
Yes.
that is that generate this xy or not. So say again back to here, let's take a linear combination. Let's say alpha time 1 1 and beta time 2 2 is equal to xy. You will get here. What is the answer then? Next is this
hello, sir.
alpha.
When you take beta equals to 0, that will give a linear combination.
Oh, can you first complete this and then?
Let me finish that. Then what you have here? This
I
is
want to ask one
beta.
question here. Sir,
This is 2a.
for checking whether this spans entire R2 or no, we have to check whether this forms the basis or no, right? If
Okay,
this forms the basis, this forms the basis, then only it can.
Actually,
entire
the
R2.
previous one, as here it forms a basis, but here is as this will not form a basis. We will do that. Let's check that.
Yes,
Okay,
sir.
we are
Yes,
checking
please,
this.
sir.
Okay, sir. Fine.
So you have alpha plus 2 beta and 2 beta. So you will get equation here 2 beta is equal to y, and this is alpha plus 2 beta is equal to x. So you have beta equal to y by 2, and alpha is equal to x minus y. Okay. So you have x alpha is equal to.
So both the
alpha
coordinates will be alpha plus 2 beta.
Yes, sir.
Oh, so that's the alpha plus 2 beta. Oh,
2 beta.
sorry. Oh, sorry. Alpha plus. I made a mistake. I was going to the previous. Okay. So means, okay, alpha plus 2 beta is equal to x, and another one is alpha plus 2 beta is equal to y. Okay. So now you have a system of lead equation with the such thing. So it implies that x is equal to y, right? Because left side of both equation are same. So it means x is equal to y. What it says?
It says that x and y are equal. Points are like 1 1, 2 2, 3 3, 4 4. And
It
points
says
missing are
that
1 2.
it will not possible. If you change, suppose x not equal to y, it will generate. No, never. Because x cannot be equal to y. Getting? No. If you are going with this as we are going, okay, but we got x is equal to y. Suppose you have x not equal to y, then it will never happen. Suppose x not equal to y. Let's say x is equal to 1. I'm letting
Then it would never fall in that domain.
it will not give you a solution. But means
Exactly.
this system has
It will
no
not span
solution.
entire R2. It will not span entire R2.
What it
Both
means?
cases, whether x is equal to y or not equal to y,
it says that it will
it's
not
going to miss
generate
some
whole
points.
R2.
But sir, it will generate subspaces of R square.
That is one thing.
Yes,
That is one
subspaces. It would generate subspaces, but it would never generate entire R2.
Yeah.
So is it clear when set is form will be a span or not? We took two cases differently. We take 2 1 and 1 0, and this is a set we took, and another set this one. And one by one we check and got that okay, this generates whole R2, but this is not. Saying to be a span is equal to R2, but span of this not equal to R2.
Okay, sir, got it.
Clear? And this is the way you will check. When a system has solution, okay, then no matter, okay, span is possible. Means span of these vectors are R2. It can generate whole R2. But the system has no solution, then that means it will never be the span of R2, of that vector space or R2 if you are going to be the R2.
So can we go with your slides so that it is
okay? So yeah, let me.
helpful in quiz also.
So two of you has raised hand also. Like Ajay is, I think Ajay, where is head done? Ayush, you have
Yes,
one
sir.
question.
I have lots of doubts. That's why.
Okay, what are the doubts? Maybe we will cover in the slide if it will match with your doubt.
Okay, I have doubt activity on 4.1, 4.2, 4.3, 4.4 also.
So please solve some question related to weak for.
Yeah. So let's go with the slide. Then I think I use question let me
Yes,
tackle
sir.
also. Okay.
That's first. Right.
Okay. So
Already
I have this question. This is a span. What is the span of this set? And right? This is also a vector space. Only real line is also a vector space over R itself with respect to usual addition and scalar multiplication. Okay, means real line is also a vector space.
Yes, sir. Sir, it would be a line.
Yes, sir. Or
it would be a
is
line, sir.
Line y is equal to 2x.
Yes, sir.
Yeah.
So here is the question: what is the span of these two vectors? See, this
y is equal to
vectors
2x.
of R means R is forms a vector space over R. So what will be the vectors in this vector space? Single real numbers. These are the vectors in this vector space. Please stop me if you have doubt. If you are not getting that how these are vectors. Okay.
So can you repeat?
Why?
See, I am saying this is real line R is a vector space. R is in this course we are taking field as this inside R polar. So real line itself a vector space on itself, right? R is vector space over R, mean to say.
Okay, got it.
Okay.
You mean to say
what
this
are
is
the
R power
vectors?
1?
What are the vectors in this vector space? Single real numbers, right? These are 0
The
minus.
points
These are the
where
vectors.
y is equal to 2x.
So it would be axis, x-axis and
No,
y-axis.
y you cannot take y equal to 2x, then it will be R
Yes,
square.
yes. It would be
just
a
No,
single,
the points where y equal to 2x, like 2, 4.
Y equal to 2x is not here the case. This is we are only working over R. There is no R2. Only this is this is only R, not R2. So don't confuse with that. That's why I'm saying this is a vector space over R. Real line is a vector space over itself.
Vector elements are a single element.
Vector elements will not in a pairwise. It will be a single real number. These are the vectors.
Yes. Single real number. Yes.
Okay. So now you have a set of this vector space. Let's say I'm making over R also for more precise. Okay. Now you have two vectors. This set contains two vectors. Okay. So is that span of this set is R or not? Means what will be the span of this? The question is what is the span of this? What is the span?
1, 2.
Only one.
Only one and only 2.
Why?
Yeah, R is the span, I think.
R is the span itself.
Because we can generate
span of this is
1, 2.
R. Let me explain you. Okay.
So can you explain span of R with another example?
Yeah, I will discuss that. So let's take the linear combination of these two.
Alpha plus 2 beta.
Alpha 1 plus beta 2. These two are vector. Okay. So what is alpha? Alpha is a real number. Beta is a real number. So what will be alpha plus 2 beta? And alpha beta are real number. What it means that any real number can be generated by these two vectors. This linear combination can generate any real number, right? Because alpha is any real number, beta is any real number. Still, if you have confusion, let's take a real number. Let's take a vector from this set. Okay, let's take a vector. So what will be the vector in that? Any general vector you can say, let's say x. Again, any general vector, let's say v. If you are confusion with x, y, let's take a vector v. What is v? V will be any real number. These are the vectors in that. So v will be any real number. Okay. So is these two vectors generate this v or not? Then we will say span what this set is the span of.
It is a set of all reals.
Sorry.
So it means this is a set of all reals. The span is all reals.
Span of this is actually real number. We are proving it, how it's happening.
Yes, sir. Now I am getting it that we can form any point or any number with
So
the
let's take
combination
a
of
vector from this vector space. I am taking a vector, let's say V, any general vector. And V, what will be vectors are in this vector spaces are real numbers, means any real number will be V. So let's take alpha time 1 plus beta time 2 equal to V, right? We want to find alpha and beta. So alpha plus 2 beta is equal to B, what it means, or you can say alpha is equal to B minus 2 beta. Okay. So what it says?
So it's
What
straight
it,
line.
Sir, alpha is dependent on beta.
One equation, two variables. So
actually
value of alpha depend on beta.
Alpha, okay. Another interpretation.
any
Actually, this
value
is
of
a system
alpha
of linear equation with one equation and having two variables, right? This is a system of linear equation which contain only one equation, and alpha beta we are trying to find. Alpha beta means two variable. So this system has infinitely many solutions.
Yes, sir. Yes, infinite. That's what it would be set of all reals, all real numbers.
So if you are confusion with V, let's say I am taking V equal to 5. We took a vector, so let's say V equal to 5. So let's substitute here, alpha is equal to 5 minus 2 beta. So what it says that I want to find alpha and beta. So let's take beta equal to 1. Because this system has infinitely many solutions. So I can give any value to beta. So then what will be alpha? Alpha is equal to 5 minus 2, which is 3. So what it means that if you take linear combination of alpha is equal to 3, beta is equal to 1. Then take linear combination here, 3 into 1 plus 1 into 2. It gives 5. What it means that, oh, see that this linear combination generates 5 also. Similarly, any vector, in place of 5, you take any vector, this equations itself says, okay, span of this is 5. I think many of you confused with the, only we are working in real, that's why many of you confuse system of equation or infinite. Is it clear to all of you what I am doing here?
Yes, sir.
Yes, sir.
So the word
Yes, sir.
span, it means that like what is exactly the span? It's the value of alpha, beta, or the vector, or what?
Span says like span of a set. The definition is the span of a set. And span of a set, let's say a vector, assuming to be a vector. Span of a vector, span of a set which contains vector. So span says linear combination of vectors. All, what is span? All possible. What is span? All possible linear combination of that vectors. Span is all possible linear combination of those vectors. Like just now we discussed here, let me back to with the in R2 it will visualize easily, you can visualize. Okay. So as here you have these two vectors. So you collected the all possible linear combination, right? You collected the all possible, these are the possible linear combination, right? Just collect this. This is the span of these two vectors of this set. Just collect these points, right? All, this is the all possible linear combination, and actually all possible means it actually generates the, actually these points are actually of R2, means span is generates R2. I don't know, let's see. Okay. Is it clear what I'm saying? Span
Yes,
is collection of all possible linear combinations, as here you are looking in geometrically also you can see.
Sir, in R2 it's absolutely clear. So what is the
in this real line, it's make confusion.
Yes,
But
yes.
the same thing I am doing. I am not doing any different. Same as alpha, beta, and made an equation, and I interpreted. Okay, this system has in. Just take your time, and you can easily understand with the relate with the R2 and R. Okay. I have next one the same question. With this R2. Let me see. Span is Nikhil is saying okay. So again here, I have the same.
That is already discussed.
Just now I discussed this. I am changing it here. Okay, I am changing it. I am adding a vector here more. Let's say 2, 3. Now what will be the span of this? I changed. What is the answer to? For this one, actually, span of this is R. Span of this is R. Because you can see that I took a general vector. For example, I took 5. Similarly, you can give any value V. You can give any value to V, and you can get that O. You are able to find the alpha and beta. Means this system has infinitely many solutions. Means you are able to find the values of alpha and beta. It means in such case, span of this is. Okay, I'm changing here. I'm adding again extra vector 2, 3. Now what is the span of this?
R2.
Okay, let me listen to different student, another student. Anyone?
Still it is R2.
I have an idea, sir. For if we find the basis.
No, sir, it is not
then
whole R2.
One
But here it cannot be whole R2 because it's 1, 1, 2, 2, right? We just saw it.
We are going to eliminate.
I added here. Please listen. I added an extra vector 2, 3.
Yes, sir.
Then it will.
In such case, I am asking. I slightly changed the question because just now we discussed this question. So I have slightly changed.
It would be R2.
Now
R2.
you have this.
R2, sir. R2. You just ask me why. Because
yeah, I will.
We have to eliminate either 1, 1 or 2, 2 because these are multiples of each other.
Or you can take the
taking one of them and 2, 3
of
make them
1,
independent.
1 and 2, 3.
And the span is R2.
Okay, so you are eliminating no matter. Okay, you can eliminate. I'm saying don't eliminate. Okay, now my other question: without eliminating, if I will ask the answer, how you are, then how you will answer this without eliminating this 1, 1 or 2, 2.
Sir, is
So
it like
1, 1
we
and
have
2, 3 linear
1,
combination
2,
will be
2?
R2, and we can make coefficient 0 for 2, 2.
Sorry. There are
Sir, any linear combination associated with these 3 elements, again it will be R2.
Okay. Can you say again?
Sir, any linear combination.
You have done. You can continue.
That 2, 2 is the linear combination of 1, 1. So.
Okay.
Sir, can we say that
so we can
a superset of basis is
2, 3 is
span of
linear combination of 1, 1 or not? But we can see 2, 3 cannot be. 2, 3 is not a linear combination, so it's linearly independent, and it's in the R2. So we can span of this is R2, sir.
Okay. Anyone else? Yeah. Okay. I got your
sir,
idea.
it is a superset. And so, sir, I want to say okay. every subspace is a subset of itself. And a superset of basis.
Every subspace is every set is subset of itself.
Yes, sir. Like R2, it is a subspace of R2. So if we, in this example, if we take, this is a superset. And every superset would be only one vector is dependent on other two. So every point can be created using those vectors. Even if you keep on adding vectors in this, then also it is a spanning set of same R2. It doesn't matter.
Okay.
add 2 or 3 more vectors, then also it is R2.
Okay, yeah. Okay, anyone
Sir,
else? Huh.
Sir, just correct me if I'm wrong, if my interpretation is wrong. So we have 1, 1, 2, 2, and 2, 3. So 1, 1, and 2, 2 satisfy this condition like x equal to y. So that is satisfied. And then we have 2, 3, which satisfy the condition x not equal to y. So x equal to y and x not equal to y, which covers the whole R2.
Cover the whole. Okay, yeah. Okay. 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 So, okay. Let me go with the same idea as just now I went here. The same idea. Okay. We will check that is that set span whole R2 or what is the span of this set. Okay. So again, what is the definition of span? Span says collection of all possible linear combination. Okay. So the question is, what is the span of this? Okay. Of this R2. Okay. Let's take a linear combination or assume or differently assume that, or no, let's go with the I will go with the two ways, because you may have confusion with the two ways, so that's why you may have confusion with the one way. So let's go, I will go with the two ways. The first way is assume that span of this set is R2, and another one is assume span of this set is not whole R2. One is that not, and the second is maybe. Assume, okay, assume span of this is R2. So what it means that let's take a vector from this vector space. Again, I am saying let's take a vector xy. Okay. Now, what is span said? If you assume that okay, span of this is R2, it means that linear combination, okay, of this any early or there exists a linear combination, means there exists, or maybe there is a linear combination which give this xy, this vector. So let's say alpha time 1 1, beta time 2 2, and gamma time 2 3. 2 3 is xy. Okay. Now you have this equation. Just form the system. It will form a system of linear equation. It will be alpha plus 2 beta plus 2 gamma is equal to x, and alpha plus 2 beta plus 3 gamma is equal to y. This will give this equation, means in this coordinate wise, will give a two equation. This is a system of linear equation where we are trying to find alpha, beta, and gamma. So if you solve this equation, this says that if you see that these two are equal, just subtract, then it will be give like this is 1 and 2 to equation 1 minus 2, means to say it will give minus gamma is equal to x minus y, means gamma equal to minus x plus y. You got a gamma. Okay. Now just substitute here alpha plus 2 beta plus gamma is equal to minus x plus y is equal to x in the first equation. If you substitute here, it will give alpha plus 2 beta equal to this in this side to this side, it will be 2x minus y.
We are going to get infinite solutions for this in the end.
So see that actually this system has infinitely many solutions. If you very much comfort with this system of linear equation, actually this is happening. You get a value for alpha, sorry, gamma, but you have a relation this one. This implies that alpha is equal to 2x minus y minus 2 beta. So this says that okay, if you give value to beta different, because alpha and beta are any real number, so you can give the different value to beta and it will give different value alpha. So actually what it means is this system has solution. What he said that this system has solution. you are able to get, if you are assuming any vector and you are taking this linear combination, you are able to get alpha, beta, and gamma, which gives the linear combination of using that alpha, beta, gamma. It will give xy. It means it says that span of this is R2. Previously, you have seen that if you took only these two, the span of these two vectors is not R2. But when you added this, it gives the whole R2.
Sir, you mean to say that if we have infinite solutions for this, then it covers entire R2?
If you have not infinitely, if you have unique solution also, then means
Yes.
solution. Means
Yes.
solution. If you have solution, means says okay, this means the span of this is R2. If you have solution, because you are able to get alpha, beta, and gamma. That's all. You want alpha, beta, and gamma. Why it is? Because we are just writing as a linear combination.
So it means, sir, if we have a unique solution or infinitely many solutions,
then entire R2 is spanned.
If you have unique solution and infinitely many solution, means this span of that set is R2. If you have no solution, in such case, as just now previously we did for these two vector only. In such case, then span of that is not R2.
Okay, sir. Thank you. Clear, sir.
Now I go on through with this one. Maybe because we thought, okay, maybe in such case, suppose.
Can I interrupt here once, please? It's very nice to that you explained. Now you explained earlier that if it is like 1 1 and 2 2, the equation will not really resolve to anything, right? Alpha plus 2 beta is equal to x, and alpha plus 2 beta is equal to y is what it is going to come. X is equal to y.
Yes.
That is also x is equal to y is like I'm getting a straight line.
X is equal to y, only a straight line. Yes.
So,
but we want whole R2. It gives only xy if you are interpreting with this geometrically. If you are interpreting with geometrically, so that equation give only this line, but we want whole R2. What it means that it's not generating whole R2.
Okay, that's the reason why we say it is not the span of the set.
That's why the reason is the span of that is not whole R2.
But sir, that is given
R2, right? But I just want to clarify the nomenclature here. Span of R2 is not represented by that set, but 1 1 comma 2 2 represent a straight line which is passing through the origin, and that itself can be a span, correct?
Actually, span is always a vector space.
So that vector space of 1 1 2 2 is defined, but it is just that it is not
whole
covering.
Not covering whole R2. Correct.
Okay. All right.
Span is always a subspace. Means vector means a span is always a subspace of that the bigger space.
Bigger space. And when a span represents the entire vector space, that is what we call it same, is it?
If span is generate whole R2, then span of that. Yeah.
Sir, can you please write? I want to ask in R3 a question in R3. I want to clarify one thing. Sir, can you write one? Write these points, sir. 1 0 0
0 0.
Sir, say 0 0 1.
0 0 1. Okay.
And 0 1 0.
0 1 0.
If we are asked that what is the span of this, then it is R2, right? Because
not R2. So, means not. It will not seem to be R2. It will not R2. It is a subspace of.
Sir, R3. I have not completed my question. My question is, x coordinate would never come out of these two vectors. We can never span x coordinates.
Correct.
Right. Y and z coordinates we can span. So that is why I'm saying that the vector space which these two vectors would be spanning is R2.
So you will not say R2. Say subspace of R3 which have dimension 2. That's the proper word.
Okay.
That's the proper mathematically. If you say this is R2, then mathematically this is not true. The proper word is the span of this is a subspace of R3 which have dimension 2.
And what can we infer about the dependence and independence of the variables involved in the vector?
Okay. The cases is when you have very much clear that okay, that set span the whole vector space, then next thing is you have to check those vectors are linearly independent or dependent. Suppose you have a case. Suppose we have a cases. Suppose as here you know that this new my new question means containing this vector. This generate whole R2, okay, but these three vectors are not linearly independent. As you can always looking from the starting, this this 2 can be written as 2 times 1 1. So if you have a set or sorry span, means you have a set which generate whole R2, but that set does not contain linearly independent, so that cannot be a basis. If span contains, like suppose the case is here 1 1 2 3, in this case actually this generate whole R2 and these two vectors are linearly independent. In that case the basis word comes. Okay, if it spans and vectors are linearly independent, then that set is actually a basis of that vector space.
Hello,
Okay,
sir. Can I interrupt you?
So, sir, in this question,
Sir,
1 1
in
and
this
2 3 are called the basis of this set.
Okay, just 1 minute. Okay, let's finish. Let's finish. Okay.
hello, sir. In the question 1 1 and 2 2, so that is form span of R2. You have said that that is a not form
No,
span of
span.
R2.
So see, 1 1 and 2 2 only, not the span of only this. If you form this set, this is not a
Yes,
span
this
of R2. But I'm saying include this one also. This 2 3.
yes.
In that case, it is span R3. Sorry, R2. It spans R2.
Sir, in question 1 1 or 2 2, that is given unique solution.
1 1 and 2 2 gives no solution.
Conic solution.
Previous one, as just now you have seen. In that case, you are not getting no solution when you assumed any vector.
Okay, sir. Okay, sir. I confused. Okay, sir.
Continue.
Sir, I wanted to ask one question regarding the rank of a matrix actually. Sir, if I have a matrix of dimension or whatever, 3 into...
I want to interrupt. Let's finish this one. Then I have question for rank also.
Okay.
So, is it clear to all of you that what I just now discussed? I hope I tried my best. Okay.
Sir, in this question, so we say that 1 1 and 2 3 are the basis of that vectors.
Actually, this is actually because of this vector is written as this one. So you can not eliminate, means saying the whole set is not a basis, but if you take the subset of this set, means containing these two, this is the basis of R.
Okay.
What is the answer?
Sir, can you please repeat what is the basis of the matrix?
Matrix, not matrix. This vector.
Oh, sorry, vector. Sorry, vector.
So actually, what I made in this new question, this is not a basis, but I took a subset of this set, which is I am taking this one. This is the basis of it. But this span, this set, span of this is not your basis. The reason is this spans whole R2, but the vectors are not linearly independent. These two are dependent, means this can be generated using this one. Okay. When the span contains linearly independent, when the span means that set span whole R2. When the spanning set contains linearly independent, then that set is a basis. Otherwise, it will never be a basis. Okay, it can span, but we will not call him or call it basis. We will not call it.
We can say that this is a spanning set, but not minimal spanning set.
Now the concept is minimal and maximal thing. Actually, this is not a minimal something. What is that definition? Minimal and maximal?
Sir, it should be a minimal spanning set or
sets.
maximum linearly independent set.
Minimal spanning set. So this is not a minimal spanning set. No. What is that? This is not a minimal spanning set because it contains a vector, but not a minimal. If you take the minimal of it, we want to find the basis of it, means reduce the vector from this set. So reduce the vector, let's say I'm reducing 2, 2, or let's say reducing vector 1, 1. I'm eliminating this vector from that set. So 2, 2 and 2, 3, or 1, 1, 2, 3. So this is, if you using this one, you are just minimize it this set to this one, and reduced this set to this one. Now this set actually span R2. That's the minimal thing. Says minimal spanning set. Or differently, also sir have given the different definition. Not different definition. He just what he was doing. What he was trying to do, he took a, let's say you have a vector space, he took a vector alpha, we took a vector v1 and took span of it. If it generate v, then fine. Suppose it not generate v, then took another vector, let's say v1 and v2, okay, and check that span of this is v or not. If it is happening, then fine. Then actually the definition, that's why I came minimal. Actually, this is the minimal spanning set. If it is not, take another vector v1, v2, and v3, and check that span of this set is v or not. So that is the process, and that is in that case the word came minimal, because minimally you are going to, like, I just added a one by vector and checking, okay, span of that is whole v or not.
One question here. Sir, minimal set, minimal spanning set, and maximal linear independent set, they are one and the same thing. The set would remain the same.
Minimal is different, maximal is different, right? Maximal linearly independent and minimal is spanning set. These two.
Both are equivalent.
So they both can be same or they both cannot be same.
If that set is a basis, then both are same. If that set is not a basis, then both are different.
Okay.
Sir, if it is a maximal linearly independent set or minimal spanning set, then it is already a base. So
yes, sir. My doubt is this. Then it is already a base, because even if you take minimal, then it is linearly independent, and maximal linearly independent, all the elements
So
are linearly.
that's why I said
They are the basis. These are the one and the same thing.
If that set is basis, it will both follow. Means in that case, both are same. Means minimal linearly or minimal spanning or maximal linearly.
Sir, but why we are saying if that is basis? It is not basis by that thing only.
Yes, sir.
Suppose if that is not a basis, then those two are different.
Sir, can you take an example where both of these sets are different?
Okay.
And they satisfy all the three conditions for minimal and maximal.
Okay. Okay. So I am taking vector space R3. Okay. And also I'm taking vectors. I am taking a set which is 1, 0, 0. Okay, and 0, 1, 0. This is a set, and another set is this one, 0, 0, 1. Okay, this is a set. I'm taking another set also. 1, 0, 0, 0, 1, 0.
It
0,
should be in
0,
same
1.
vector space.
These are the from this. Okay, should be same vector means.
Same vector space, that means you are taking
Sir,
this,
suppose the first example you have written 1, 0, 0 and 0, 1, 0. Right, sir?
So I took three sets differently.
Yes, sir. Let us talk about the first set. Sir, it would not span R3.
It will not,
because you are never going to have Z coordinate.
Yes.
Okay.
So this set, we cannot say that this set spans R3.
So, what
This
is
is
happening
not a
here?
maximal
This set
linearly
is
independent set.
this set is linearly independent, but this
Yes,
is
sir.
not a maximal linearly independent.
Yeah.
But sir, at the same point, it is not also spanning R3.
Okay, no matter. But I'm just asking, it is a maximal linearly independent set in R3. So the answer is not.
No, yes, sir.
Maximal linearly independent set in R3. No, because there is another vector which also linearly independent, and in that
which also needs to be taken for spanning R3.
For R3.
Yes, sir.
This set is actually maximal linearly independent. If you check that, it actually generates whole R3.
So we can say that this one is the basis, but of R3. But the above is
Sir,
not the basis.
What my question and my other friend was also asking, if the independent vectors span R3, right? Then they have to satisfy the condition that they have to be minimal spanning set and maximum linearly independent set. So they both have to be equal.
If that set is following both conditions, then there is nothing. That set is basis. That set is a basis.
Sir, in human spanning set or maximum linear independent set, that will be represent whole R2. Otherwise, it can't be maximum independent linear independent set.
Sir, but you said earlier that there is a case when this will not be equal.
There is a case where this may not be equal.
Yes, sir.
When that set is not a basis, then minimal maximal will be.
My request is that if the set
it will clear. This set is maximal linearly independent. With this example, it will clear. Is this set is maximal linearly independent?
Yes, sir, it is.
Yes.
No, sir.
No, sir, because
why?
One and two,
can
you get the
110 is written as a linear combination of
first
two.
Yes, sir, yes.
Yeah.
This is not a maximal linearly independent set. Okay. Actually, this is not a linearly independent set. That's the reason. It contains the vectors which are linearly independent 3, but another vector which is not linearly, that can be written. So this is not a maximal linearly independent set. Is that minimal? Okay, again, now you have seen with the maximal term. Is this set is a minimal spanning set?
Yes.
R3 of
No,
R3.
sir. No.
No, sir. No, sir. No.
It is of R2. It is
because
of
it
subspace.
require again a vector this one.
Yes, sir.
Okay. Now let's come to this one. Is this a minimal spanning set?
Yes, sir.
Yes, sir.
Yeah, actually it generates whole R3.
Yes,
Sir?
it is, sir. Because it
Again,
is a
hello,
standard
sir?
basis. It is a
Next
standard
question.
basis.
Next question. Is that this is
Hello?
a minimal spanning set? Let me finish this one.
No, sir.
This.
No, sir. Because the fourth one is dependent on first two.
Hello, sir. Hello.
Hello. Hello. You can escape. You can speak. You can continue. Hello. Am I audible?
Yes, you are audible.
Yes, sir. You can.
Actually, a discussion is going on. If you can wait for a moment, sir is explaining something.
Okay. So actually, see, this is not a minimal spanning, because it spans, but not. It contains extra vector. Till here, it can generate, but it contains another vector. So it is not a minimal spanning.
That is what
I am trying to minimize it. But it contains extra. So actually, this is the minimal and this is the maximal linearly. This set is a minimal spanning set, and this set is a maximal linearly independent set. And both cases says if that set is satisfying that condition, then that set is called a basis of that vector space.
Sir, if one is satisfied, isn't the second one is satisfied?
Okay, now I am getting your point.
So one body asks if one is satisfied.
Can you write an example where the set is
one body has asked that a very interesting question he asked, if a set is satisfying one condition, is that satisfying another condition or not?
Yeah, it is satisfying, sir, I think.
No, no, for
because
this set you
It has
see
to
that
cover, sir,
for
it
this
has to,
set
yes, sir. For this set,
for this set it is not a maximal linearly independent set. Okay, okay.
and
Okay.
also both case is not satisfied in that case, sir. Suppose, but in this basis of R3, if one case is satisfied that it is a maximal linearly independent, then it is already satisfied that it is a
Minimal, yeah, correct,
spanning set.
correct.
Yeah.
So if
Yes,
one condition will satisfy, then another will also satisfy. Yeah, correct.
that was my question. If it has to span R3, then both of these sets, they would be equal.
Need to be equivalent. Yeah.
Okay.
Yes,
Oh,
sir.
that's no. That's why many of you confused when I said that these two are different. Okay. Oh, okay. So actually, it will the condition when maximal linearly independent set is maximal linearly independent set in that vector space. So it will be the minimal spanning set.
Yes, sir. That was my argument.
Yes,
Sir, where both are different? Maximal
Yeah,
spanning set
actually,
and
I said it will different, but the case for the basis, actually, it will not different. Yeah, I made a mistake there. It will not different. For the
okay,
case
sir.
basis, if that set, suppose in a vector space,
yes, sir.
Set contains maximal linearly independent, so it will be the minimal spanning set of it.
So that means both
I
of these sets in.
I made a mistake there. Sorry.
Oh, no problem, sir. But in the end, can we say that if it spans R3, if a set, minimal set, or maximal linearly independent set, this would be the same if it spans R3.
Yeah.
Or R2, or R5, or R4, any
whatever
any vector space.
I don't know. Just now we discussed of many of you got or not. I hope, but we are trying to discuss with the example.
Sir, in lecture 2, Professor explained this. What we said.
So I hope what we just now discussed got it right.
Yes, sir. Yes, sir. Got it, sir. Got it. In a vector space, they would be equal. This is what I.
So let's move to the next question, which I have.
Can I interrupt you once?
Sure.
I think you guys were discussing about maximal linearly independent set and minimal spanning set, right? I just went. So the thing was in discussion that if one condition will satisfy, then other needs to be satisfied as well, right?
There is already satisfied. If one is satisfied.
If one is satisfied, then it will come to the second. That if the set contains maximal linearly independent, then it will be the minimal spanning set.
Yeah. So you guys were discussing that if it will be the maximal linearly independent set, then it will be the minimal spanning set also, and the vice versa will be also.
Also, vice versa will also happen.
So let's go to the discussion.
Sir, I have a doubt in the rank of a matrix, sir.
Yeah, I will go. I will rank. I will go.
So, sir, let's go to the definition of this both thing. That what is maximal linearly independent set? What I understood is the maximal linearly independent set means that it gives all the linear combination of the vector space which are linearly independent, right?
No. It maximal linearly independent set just collect the all possible linearly independent vectors from that vector space.
Yeah. Yes.
That's what exactly what I said, that it contains all the linear combination of the vector space which is linearly independent set, right?
Don't use linear combination, because how the vectors, if two vectors are linearly independent, they will never written as the linear combination.
Yes.
What I mean to say,
yeah.
Collect the all possible linearly independent vectors from that vector space and form a set that is the maximal linear.
Okay, sir. Let's take any minimal spanning set. Let's take 0, 0, 1, 0, 1, 0, and 0, whatever 1, 0, 0.
Okay.
And can we take one more linearly independent set? We absolutely can take, right?
We cannot take.
Actually, when you took the,
I think we can. No, we can't take. Actually, we can't. Yeah, I understood.
Sir, in this question, option 1 and 2 are correct.
No,
okay, let's continue with the question. Continue with the question. In that we will discuss this maximal and minimal. Will come.
I understood. Thank you.
Okay. So in this question, which option is going to true?
4, sir. Option 4.
Option 2.
Option 2.
Option 2.
4. 2.
Okay. Anyone else getting different?
Sir, I think 2 and 4 both.
2 and 4 both.
Sir, why not 1?
Sorry, it would be option 2, sir.
1, 2, and 4, sir.
Yeah, so I'm listening all of you. What's happening? Okay, so somebody says 1, 2. Okay, and anyone else we getting 3 also? We will see that. We will see precisely. We will see that what will happen here. What's the span of this? But what you are getting, just write on your copy the meaning of it. Just write the span of meaning of span. Just write yourself on the copy and see that what's happening. What if you take the linear combination of these two?
Yes.
What it gives?
It gives option 2, sir.
Yeah.
Diagonal.
Option 2, sir.
Yes, sir. Option number 2.
Option 2. That question present in activity.
Sir, in this question, option 2 and option 1 are same, na? Identity.
No, identity matrix.
Identity matrix is covered in identity matrices is the subset of diagonal matrix.
1001 for 2 cross 2 matrix is the identity matrix.
No,
So
you need to write
actually
linear combination.
it will give a identity matrix, but a particular vector. Identity matrix is a particular vector, but a span is span is
That
a
is
vector
what-
space.
Yes, sir. That is what I am saying. Diagonal matrix.
Used to a subspace, vector space. So
Identity matrix is subset of diagonal matrix.
Okay, if there is a scalar multiple, then it will convert it to diagonal.
It will change. It will change.
Okay.
So
Then
span
only
says
option 2. Maybe.
So let's see that span says all possible linear combination. So all possible linear combination.
If there are scalar multiple, then it becomes diagonal matrix.
So here is all possible means we can take any. Let's say if I'm stick with the alpha, so let's say alpha here and beta 0, 0, 0, 1, where alpha and beta can be changed. These are the linear. So sorry, these are the real numbers. So span of actually means a span is actually a vector space, or maybe if you are wording, it will always a subspace. So subspace of it will be subspace of M2 cross 2 over R. So span is in the set form. If you will write, actually span of S will be like this: alpha 1, 0, 0 plus beta 0, 0, 0, 1, where alpha and beta belongs to R. This is the mean of span. If I didn't wrote previous time, actually span is a set, and hope you know that the definition of set forming, writing like this. What it means that you are writing collecting the all possible linear combination. It says this set, the definition of this set says you are writing all possible linear combination. This is the mean. If I will say in previously for this question, if you are saying to the span of this is, what will be the span? So actually span is a set. If you are right precisely here, so alpha time 1, 0 plus beta time 2, 1, where alpha and beta belongs to R. So this is the proper thing saying to be the span, as we are just now told. Span is a set, and hope you know that what the meaning of this set. This meaning says this is the linear combination of these two vectors, where alpha and beta belongs to R. So if you write precisely here, it will be alpha 0, 0, beta, where alpha and beta belongs to R. So what is this set? This is the diagonal set, right? Collection of diagonal set, right? Because alpha and beta can be any real number. So it actually it contains a scalar also, but the whole thing is actually diagonal collection of diagonal matrices of order 2.
Yes.
Right?
Sir, only option 2 I thought.
So in that case, only the option 2 is correct. Is it all of you is clear, right? What I'm writing span on this form?
Yes, sir.
Yes, sir.
So answer is only 2, na sir?
Sorry, and the answer
Because
is
all other options are a subset of the option 2.
option 2.
And they are not the span because they don't contain all the vectors.
So I hope span word is
Basically,
clear to all of you.
sir, basically span means all possible combinations of the vector, right?
All collect the all possible linear equations. This set, the definition of this set says this one, this all possible linear combination. You are writing it.
If alpha and beta are 1 and 1, then option 1 is correct, no?
So actually, but we want this is a particular matrix. Span is a set. Talking about set. This is only one. This is actually identity is belongs to this set. Identity matrix belongs to this set. And we want span of that. This is a particular vector of, or you can say identity matrix is a particular linear combination of these two. But we want the whole. Span is the collection of whole, not a particular. Span is a collection of whole linear combination. It is a collection of whole linear combination.
So if the option were that it is diagonal matrix, would it be a span?
So diagonal is this one.
Yeah, that's the second one. Sorry.
So, so option 2 is correct because we are getting a diagonal matrix.
But you need to say, sorry, just excuse me. One element will not make a span. Is that the way we should see it?
One element
one element can
matrix. Identity matrix is 1, 1, and then the others are 0. So that is to say, is that to say only one element will not make a span, even if it makes a set?
We have to check in R2, right? Of order 2.
Identity matrix is only 1, even if you say it's order 2 or 3.
Identity
1, 0, 0, 1.
is a particular linear combination of these.
Correct.
Not a whole span.
Correct.
A particular linear combination. So how it can be span? Span means it is collection of that, na?
It has to be entire R2 and not just one example.
Not a particular vector. It should be a collection of vectors, collection of diagonal matrices. Not a particular vector. Not a particular matrix.
Actually, this answer is a basis, na? Then we are only selecting option 2, that is basis, na?
So in that, no. So this is a basis, not just asking for the span of that, not the basis what I heard. So let's move to the next question. Maybe the next question is on the basis, I think. Minimal or maximal. It contains. I think when we solve this question, it will clear more all of the two maximal, minimal, and what is the basis of it. Let's see that.
I have doubt in this question. Option number 2, sir.
Okay.
That question is present in activity.
Okay. So what is the consider the following set? This one. This is the set of correct options. Okay. From this set, we are choosing some vector like here. The first set is the basis of R3. The second is this the basis of R3? The third is this a basis of R3? So which option is going to be correct or how you are solving this? Please let me know. And I'm giving you time. Please think that, then we will discuss. Please remember or please revise your definition of basis. What is the basis? Definition. Maximal, minimal.
1 and 3 is definitely true. The other, because determinant doesn't equals to 0.
Okay.
In basis, 1 should be there, no?
Option 1.
Okay. Anyone else? Why option?
So option 1 is correct.
And why option 3 is not? You can check.
I will check.
for a vector space, the general thing is if there is a vector space, it have many more bases. Not only it will have a unique basis, it can different bases. Many, like for a vector space, there are infinitely many bases for a particular vector.
Option 1 cannot be correct because it has infinite number of solutions, and they are not unique. When they are not unique, they are dependent, and when they are dependent, they do not form a basis.
Okay.
That means that option 1 is true, right?
It is
Yes,
not
it is not a base.
No, it's not basis.
Determinant is
Yeah,
not
it is
zero.
not a basis. That's what option 1 says.
Option 1 is correct, sir, I think.
So correct
Hard
means
vector should not
it
be
says not a basis means you are
Yeah.
saying this set is not a basis.
Yeah.
It is they are
Because
saying.
it is not a linearly.
That's why I said that option 1 and 3 is true.
So option 1 and 3 is true.
So my question is,
Yes.
You are doing with this matrix thing or only just how you
Yes.
are solving this?
No,
The-
sir.
by
I
I did
matrix.
with matrix thing.
I am finding the determinant and finding the solutions of this.
Okay.
If it has only unique solution,
I want answer from the maximal and minimal term. Can you give that answer in the terms of maximal or minimal, maximal linearly independent, minimal spanning set? In that terms, can you answer these options? How, why this option is not true? Why this option is true? In that word, I want. We can apply here. Actually, it's see, basis means maximal linearly, minimal is spanning set. So you can use the matrix is the give. Okay, that's the fine. If in that word you can say also. But in this context, using this maximal minimal, can you give the answer for this? Why these options are true, not true? What's happening?
Option 2 is not follow minimal spanning, I think. Option 2 is not follow, sir, because it has 4 elements.
And certain vectors are similar.
Yeah.
And two vectors are similar. Okay.
So option
anyways,
3 is
we can
already
say
rejected.
in the maximal and minimal term that option 1 is not linearly dependent. So
Hello, sir. In option 2, we can remove.
One by one I can speak. I'm listening to all of you.
Sir, in option 2, we can remove which are linear combination of other.
So I was saying that anyways we can say in the terms of maximal linearly independent set or minimal spanning set that option 1 is not linearly independent. So any which will not give maximal linearly independent set.
Okay. Yeah.
So, it will not form a basis. And similarly in option 3 that it is linearly dependent. Independent. So it will be maximal linearly independent set. So it forming a basis.
Anyone else can also answer. So let me continue. So let me discuss that. So in this set, what's happening? You said that if you write a matrix using these vectors, you got that determinant of this matrix is 0. So what it means is these three vectors are not linearly independent. One thinks that. And so in that case, this is not a maximal linearly independent. It contains actually this set is not a linearly independent. So actually for that, in the sense of maximal linearly independent, it doesn't follow. So it means this set is not going to basis. So that's why this option is going to true, because not word is here in negation term. In other word is this set is not a minimal spanning set. Why? Because this is a linearly dependent set, and when you take a span of these vector alpha time 1 1 minus 1 plus beta time minus 1 1 1 plus gamma time 0 1 0 with the any vector, let's say x y z, if you are assuming any vector, this give no solution, because when you check that, you can check also, it will give no solution. In that case, it means that it is not spanning whole R3. So it is not a minimal spanning. It's needed more, not only this one. It's need to add extra vector.
Can you repeat that part, please? Can you repeat the last part?
So last part is, see, when you check that this system has no solution, so it means it needed more vector. It is not only it's want more need to add extra vector so that it can span. So what it means that it is not a minimal spanning. It's needed more vectors also, right?
Yeah.
And you have to, after getting the adding more vector, you have to also eliminate some vector because of maybe any one of them is linear written as a linear combination. Mean to say you have to you have to choose a vector like that so that we can make that set. You have to add a vector in that set so that it can generate whole R3 first, and it should be minimal, like it will be not a linear combination, or maybe I mixed up. Let me say again it. Like what is happening here when you got that this system of linear equation will not give will it have no solution, means this set is not spanning whole R3. It means you have to add extra vector in this set, then it will span whole R3. So actually this set is not a minimal, not because it's not spanning itself, it is not spanning. So how we can say it is a minimal spanning set?
Sir, if it produces a solution, I mean, if it gives a solution, then it would be a minimal set.
If suppose it gives a solution, suppose this system has a solution, then the case is that if this system has unique solution, it means actually these vectors are what it means that these vectors are going to be independent, right? Because you know that when a system has unique solution, then that coefficient matrix is invertible, right? You know that.
Yes, sir.
In that case, the coefficient matrix is invertible. So what it means that the determinant of that matrix, coefficient matrix, is non-zero. When a determinant of coefficient matrix is non-zero, that means when you form the matrix using this vector, those vectors are independent, right? It one by one it is giving the conclusion. So what it means that in that case, if the system has unique solution, in that case, that set is actually a maximal linearly independent set, or differently, it is a minimal spanning set. If that system has unique solution. If that system has infinitely many solutions, it means that that set is not going to be a minimal maximal or minimal also, maximal linearly independent and minimal spanning set, first thing. And actually what is going to be, if that system has infinitely many solutions, in that case you have to eliminate some vector from that set, then it is going to, then you have to minimize. You have to minimize because you have extra vector, that's why it's going gives infinitely many solutions. You have to eliminate, so means you are trying to minimize that set, and you are getting and anyhow after eliminating such vector you will get a minimal spanning set.
Okay, sir.
I hope it is clear what I mean to say.
Yes.
All of you also, not only
Option 2 is also wrong, sir.
And now the second term is in the terms of minimal and maximum. As you know, this contains the more vectors. 4 vectors are
It
here,
contains
and
more
one is
variables
copy
than
of.
number of equations. Then they are always dependent on each other. Some of them are dependent on each other. So it would never be a basis.
Basis also says to be, and different word also. Simple thing is, if you have a set, first check that those vectors are linearly independent or not. If those are linearly independent, the second thing is you have to check is that those vectors span whole R3. If you span, that's finish. If not, then you have to okay, we have a independent, but it's not completing. We need extra vectors also.
Hello, sir. When you eliminate some vector which are dependent of another vector, so then we can get base.
If you eliminate, like as here, as here we have this. This is actually what is happening here. This in this set, if you eliminate this one, then what will happen? This, if you remove this vector, then if you check that these three vectors are maybe independent, you can check what is happening here is that these three vectors are independent. 0, 1, minus 2, 0, minus 2, 1. Actually, determinant of this set using these three vectors is non-zero. So means you have vectors. These three vectors are independent. This vector is just going to extra. So if you eliminate this vector, then form this set. So this is going to be the maximal linearly independent, or differently minimal spanning set also. Yeah, Gauss, you have just eliminated this one.
Just one question on the same. When do you say, I mean, how do you say determine unique solution or multiple solutions? We know the determinant is not zero.
Determinant is not zero. In that case, you know, the coefficient matrix is invertible, and then
correct. So there is a solution or unique solution or many solutions. Which one is it that you were mentioning a little earlier?
So if you are including these four vector, so in that case, it will give infinitely many solutions.
Okay.
If you eliminate this vector till here only, in that case, it will give unique solution for this when you do this one.
Okay.
So it means that vectors means coefficient matrix is invertible, means determinant in non-zero. It means these vectors are linearly independent.
Okay. Okay. Thank you.
Sir, so when we have many vectors of which any one of them is dependent on the rest of the three, then we can say that they have multiple solutions, right?
Yeah, that's then it is good.
And only if they are solely independent, only then it is unique solution.
Unique solution, correct.
Okay.
So
Sir,
next one is
can you please repeat the point? If it is invertible, determinant is invertible, then what is the
Sir, can I repeat?
You can repeat.
See, if the determinant is invertible, then there are two options. It can be either unique or many solutions. After that, you need to check the vectors. If any of the vector is dependent on the rest, then it is many solutions. And if all are solely independent, then it is unique.
Yes, then I have to solve the equation again and calculate the value of x, y, and z.
No, that is was just checking the idea. No,
Determinant I cannot conclude. Many or
these things we need to remember. We can simply see this by.
Actually, no, to always calculate. If you see, if you form this, just form the matrix using these three vector. If you have determinant is non-zero, directly say, okay, this is going to basis.
Yeah, there's no need of remember
to always solve the system, because these things are, you can see in the bag, it's going to happen like this when we form using this, when we form system of linear equation using these vectors, it will going to be like that. Oh, coefficient will give the exactly these vectors, coefficient matrix will contain these entries, means vectors, and give the means determinant in non-zero, like that is happen. But if you have just a simple mean is just form the matrix using this vector. If determinant is non-zero, then just say okay, then matrix is going to be, that's a collection of those vectors is linearly independent. Oh, I think I missed I don't know. Just take your time, you will like whatever we discuss, just take your time and slowly you will get one by one.
So, but in the find the basis, we need to check two conditions: it's linearly independent or it's
actually when you have a set, you need to check two things. Basis, if you want to check a basis, first thing is first check these vectors are linearly independent or not. The second thing is you have to check span of this is a whole vector space or not. If these two are satisfied, then this is a basis.
So, but in this question, we check only it is linearly independent or not, or
Actually, so actually, what is happening na? This actually R3 is have dimension 3, so maybe because of many of you are getting that like R3 dimension actually says that na ki dimension says that it have three vectors are linearly at most. I mean maximal linearly independent set. Cardinality of maximal linearly independent sets is 3. Dimension says dimension what this says. That's why I just directly infer. Otherwise, even you in this video dimension word is used in this week or not? Dimension word is that done?
Yes,
it is taught.
It is used.
It is used. I have confusion whether dimension and rank.
Cardinality of basis is the dimension, sir.
I think the sir have done this. In week 5 is
cardinality is number of elements in a set, correct?
Cardinality is a number of element in the set. In this week 4 dimension word sir have used. Actually dimension is the rank word sir used the rank word. Rank or dimension word is the same for vector space. So don't be confused. Rank word for vector space is same, but rank word for matrix is different, and dimension is there is no mean for the matrix. Please be note that rank dimension are same for vector space. Okay, but when you case for matrix, only the rank word uses, not dimension for matrix. So don't be confused. These are two different things.
And in basis, how many elements are there that are the dimension? No?
Sorry?
In basis, 6 elements or 4 elements. That is the
dimension. Number of or the cardinality of basis is called dimension, or rank of vector space. The cardinality of basis is called dimension of vector space or rank of vector space. Rank is for the matrix is different thing. Okay.
Can I ask one doubt in rank of a matrix? Sir, if the columns that are present in the matrix, do they have any significance in respect to the rank, or it's only the rows that are non-zeros matter in the rank of a matrix? Like, do the columns have any significance?
Actually, there are significance means doing with the row is enough, but the word is column space and row space are two different things.
So, sir, considering the final answer for getting the rank, so in that is column required or not?
Not necessary.
So,
only the row is enough.
So we don't have to consider columns at all in any.
If you don't want to, you no need to consider the whole course. I will say if you end up with the row, because row space and column space are same. Sorry. Row rank and column rank are same.
Sir, how can it be same? Because if we have a matrix of dimension, say 3 into 4, so then there are the number of rows will differ from the number of columns. So then eventually, if columns are taken, then the matrix rank will differ, right?
Okay. You are for the rectangular matrix. You are saying.
Yeah.
So for rectangular matrix, it can be different.
Yeah, because where n into m is totally different. So, sir, how to consider for that? Could you just take an example if possible?
But still,
in this course, we are not considering this.
But still, row rank and column rank are same for any rectangular. Just 1 minute. Let me clear. Let me verify first.
Okay, sir.
Rank would be finding through the echelon from.
Actually, I asked the same question from Subhasish sir, and he said that it will be same anyways.
It will be actually for any rectangular matrix, row rank and column rank are same. Okay, for any rectangular matrix also.
You can take any example and you can calculate. It will give the same.
Same rank. It will always give the same.
Yeah.
Row rank and column rank For any rectangular also same.
Sir, but
Okay.
how? If, for example, if we have a row of a card like dimension 3 into 4, sorry, matrix of having 3 rows and 4 columns, and if we say that 3 rows are having non-zeros, or then the fourth column can have a 0. So then the rank would differ, right?
No, it will not come. If you see that, it will never come 0.
Acha,
That's the
okay,
thing.
so it's also it's always same, right?
Actually, when it will be 3 cross 4. So if you like this is happening, this is non-zero, no, this is non-zero, this is non-zero. So fourth column will never be 0. It will be in the sum. It will come a non-zero term. Okay, non-zero entry will come.
Okay.
That's the mean. That actually this can be proved. This is proved
It is
already.
proved. It is already.
Sir, when I am going to calculate the rank of a matrix, or first I arrange the vector as a matrix, then I form it as a row equivalent form. Then I calculate the non-zero columns or non-zero rows.
Non-zero. Actually, see, rank of a matrix is asking. It means that you have already given matrix. You have to use the Gauss elimination method or reduce, change it into row echelon form, and count the number of non-zero rows. That is the rank of matrix.
Yeah, I should convert it into row echelon form or reduced row echelon form.
Both will give, but the row echelon form
Row
is
echelon form is enough.
enough. Both will give, but row echelon form is enough. Row echelon form. So this is, I have this matrix. Let's do that. What is the rank of this matrix? We have this matrix.
Sir, would you
How
be
can I
uploading this
form the
PDF
element of?
after this session?
I will upload this.
Thank you.
Okay, do you want
Sir, how can I form the element of matrix? I am totally confused.
So use this equation.
It's given Aij is equal to min ij.
Oh, mean of I.
Mean means minimum.
That means 1, 1, 2, 1, 3, and the element will come from the okay.
Rank is 1.
First 1, then 2, then 3.
Yes,
Then
you know this rows.
The diagonal element.
The rank is going to be 1.
1, 1, 1, 2, 2, 2, 3, 3, 3.
For
3
diagonal
1,
element, there will not be any minimum of the 2 elements.
1, 2, 3, 1, 2, 3, 1, 2, 3.
If there is no min, you can choose one either. If there is no minimum, you can choose either.
Because if suppose this is 2, 2, so minimum of these 2 means what? 2 will come.
Okay, right.
The rank is 1.
Element will be 1, 2, 3, 1, 2, 3, 1, 2, 3, no?
So let's see that. Let me form also. So entries are Aij, minimum of Ij means Ij are these are
1, 1, 1, 2, 2, 2, and 3, 3, 1, 1, 1, 1,
1, 2, 2.
Sir, 1,
1, 2, 2, 1.
Sir, 1, 2, 2, and 1, 3, 2, 3.
This will come, no?
Correct, sir. Yeah.
Yes, correct.
Yes. Yes, sir. Correct.
Somebody has posted in chat also. So this will come. So now let's calculate the rank is processed to use the Gauss elimination. I mean, change it to row echelon form is enough. So 1, 1, 1. Next is subtract R2 minus R1. So this
0,
is
1,
1 and this is 1. And next also you can do R3 minus R1. So it will be 0 and this is 1 and this is 2.
1, 2.
So next is 1, 1, 1. Now subtract again R2 minus R3 minus R2. So it is 1, 1, 0, 0, 1.
1.
So this is in row echelon form. There is no, so rank is actually 3 here because you have 3 non-zeros rows. So rank is 3. Yes, Nikhil.
And I cannot process row and column simultaneously. This is the rule, no?
No. Just use one, only either row or column.
Okay.
Either row or column, only one operation. Either row, either column.
Sir, I have a small doubt. Shall I ask? The video, no, you have checking the subspace. Checking three conditions: 0 belongs to W, Y belongs X plus Y, additions, multiplication. So you are telling that
Your
three
voice is
conditions.
breaking for me or all of you? For me, your voice is breaking or for all of you? I don't know. My voice is clear. No?
Yeah, it is breaking.
Yes, sir, your voice is clear.
Okay.
Sir, am I audible now?
Yeah, you are now audible.
Sir, actually, you in the video, na, you have told about checking subspace, and you have told three conditions we need to check whether it belongs to subspace or not. So, actually, I could not understand that one, that 0 belongs to W and addition and scalar multiplication. Can you give some example here and so tell that?
Oh, you are asking for vector space. Sorry, subspace. Those
Yes,
three
yes.
conditions are for the subspace.
Yes, sir.
Okay. The simple example is you have R2. Okay. I am taking a subset 0, 0. Okay. Is this okay? Is this a subspace of R2 or not? Check those all three conditions.
Sir, 0, 0 वाला जो condition है ना, like 0 belongs to one subspace. That is true for everything, no? Like whatever.
Your voice is breaking. Your voice is breaking.
Still, let's say instead of 0, 0, 1, 1 here.
For me, it's breaking.
It's
Sir,
breaking
for
for everybody.
Voice is breaking. His voice is not clear.
Not clear. Okay. Okay.
This presence of a zero a vector or a zero element is the need of bases and everything, or just the subspace? I mean, by definition, it's the presence of the zero vector is only needed in subspace, right?
Only subspace.
Not a basis.
Not a basis. Zero can be never be a zero vector will be never come in a basis,
Okay,
because zero vector is always a vector. Sorry, dependent. Zero vector is always a dependent vector.
Okay, sir.
What is the importance of rank, sir, in real life?
So rank is actually not in real life. We'll say real life, not like here is needed. Rank is actually.
For example, in the last matrix, what we have solved, there are the rank of the matrix is 3.
So actually, what is use of rank is here. You will use here. See, 2 participant raised hand. Okay.
Sir, am I audible now? Sir, your subspace condition is like you have taken 0, 0 and you have taken 0 belongs to W now. Like I say like if the 0 is not given, let us say 1, 1 vector is given to me and it is being asked to check whether it is space or not. 0 belongs to W, in that case, how do I ensure it belongs to that? Do I need to
again your
take
voice
that assumption that
again your voice is breaking. Again your voice is breaking. You are not clear for me, or I don't know, all of you. Your voice is again breaking. Okay, you can just take a proper connection. You can continue. Yeah, we will back your question. Don't worry. Let's do this one. And rank. What is the use of rank? Is see rank for this. Like in real life, I'm able to say properly this time. But here is rank. What is uses? Why? Suppose you have vectors here. Suppose only you are using these 3 vectors. You form a matrix A using these 3 vectors, and you calculated the rank of this matrix using whatever you form using this vector. If the rank of this matrix is 3, that means it says that these vectors are linearly independent. And in that case, if these 3 are independent and this whole our vector space is R3, so it says that these 3 vectors form the basis. Just eliminate this one if you are not considering this one. So this forms a basis. This is the use of if you will say.
Sir, my intention behind asking this question is,
Sir,
say, for example, the rank is 2. What does it mean, 2?
Suppose if you form a matrix and using these vectors and you got that rank of this matrix is 2, so it means that what it means that it means the determinant is going to be 0 of this matrix. Or other word, if the rank is 2, it means that these three vectors are not linearly independent. These three vectors are dependent. If you see in videos, or have I clearly told it about this?
So right. Can you once keep the minimal spanning and maximal independence definitions once?
Minimal spanning set or maximum? No. For this one.
Yes, sir. In the PPT.
Okay. For in the video lecture, I said.
No, sir. Just now you have explained the definition, sir. That definition.
So yeah, actually, many times I just said maximum. Many times I said what is maximal or what is minimal spanning set, and we did the question also. Some question also we did. So if you watch again, that maybe it may clear, because we need to finish this one also.
Okay, sir.
I hope you don't mind that, because we need to.
Sir, thank you so much. No problem, sir.
Actually, I see if you have confusion, Subhajit also took that. If mine is not clear, you can see.
Sir, I have one related doubt. In a question like this is activity 4.3, sir.
Okay. First, let me. Somebody has raised 4 people have raised 10.
Sir, actually, I have written my question on the chat. Could you please read that?
I have seen. Yeah, I have seen that. So you are still in the subspace word. That's why I'm not considering here, because see, you need to, if you want to check subspace, you have to check the 3 condition. If you are confusion with the 0 is needed or not. So see, sometime in some book you will see that he will check only the first 2 condition. 0 will never. He will not check the 0 condition. 0 is that is not. But in some book you will see that, like in this video lecture for this course, you are looking for the 0 also. So actually, if you check that only those 2 conditions, it may not be also. I have to check for that. If you check 0 is not. If you check only the first 2 condition, means closed under scalar multiplication, closed under vector addition. If you check only these 2, will not suffices. Actually, it will suffices. Actually, it will suffices. There is a theorem on that. It will suffices. If you check only these 2 conditions, closed under addition and closed under scalar multiplication and closed under vector addition, it will suffices to saying 0 vector is itself in that. Actually, there is a theorem, because if you are saying 0 if you take 0 a scalar multiplication 0, if you are saying that is a close under a scalar, say what I am saying, you are clear? No, first let me clear what I am saying. Is it clear? No.
No, sir. Let us say if you are asking a question that one vector you have given, and in that case, if you're asking me to check whether it is a subspace or not, I am not getting that 0 in that. That 0 does not contain there. So how do I check that? Okay, whether the first.
So if 0 is not there, then that set will not going to be a subspace. And you have to check first 0 in that or not. Is it clear?
Okay.
Sir, I just have one doubt in the mock question, like just with one option. So associativity of vectors in terms of addition, is that a condition for it to be a vector? Because in those 8 conditions, I think associativity is there. But when I gave the mock and we got the answers like in that portal, so there it says that associativity is not to be considered as one of the major factors.
but best thing, there is a word used in the best. What is that proper word? Best answer, something best possible. Not see, associative
Yes,
is
sir.
needed,
Best options of.
but best in that you have to choose two
Associative
best.
is extension to
So, but best
close.
can be according to everyone, it could be different, right? But it is one of the conditions. So, I mean, for some it may be, or some, I mean, it is very subjective. Like I
No,
consider.
it is not going to subjective. If you are associative, see, if you only check a condition for first two and you are checking associativity, it will never give you true answer. It is not going to a subspace or whatever will be. But for checking a subspace, or what is the question? I don't know. Where is that question?
Not subspace, presence of a vector, I'm saying. I mean, for it to be a vector, there are 8 conditions, right? And so I chose like 2 conditions out of it. So then
This one, no?
yeah. So yeah.
For which question is that?
Sir,
The
no,
same.
sir,
The
vector
same.
space. Yeah, sir. 10th one,
Okay.
I think,
Condition
yeah.
for the must be satisfied for a vector space. So
Yes.
best two answer you have to check. Okay.
Acha, so associativity, even though it is one of the 8 options, it won't be. Actually, I wrote that, but I got it wrong.
Even I wrote that.
Yes, so me too.
But then, sir, it would differ now. I mean, if in exam,
Yeah.
if it's like that, then I think it would be like
It should
a
be
problem.
existence of additive inverse, because without
First
if
I chose
additive
4,
inverse,
5, 7. Then I saw in the 2 best possible option.
If-
So I deleted 5. My bad.
Actually, in that,
that is
you
what
have
I am
to
going to
best,
tell you.
best
Because
two thing you have to choose. Like for
So
vector,
how can we say
How
best
can
two?
we
Like, because
say that is the
additive
best?
inverse and associativity both are in those 8 conditions.
Achha, those are included in the 8 conditions.
Yeah, all are all
sir.
both are there in the 8 conditions, sir.
Yes, sir. So how can we
But I
predict
think
which one
Subhashish
is
sir has said some 3 conditions that you need to must check, and the other 5 you can ignore at times as well. It's not always.
Actually, I see associativity.
So in this,
most of the
in
time
those 3,
follow.
yeah,
But
in those 3, these 2 is included. Number 4 and number 5. That I remember. So you
Sorry?
can go to the
I
previous
didn't get.
session. No, Subhashish sir have said 3 properties that you need to must check in all the options in order to check whether it is a vector space or not.
Sir, actually, it's very confusing because all
Yeah, it
8
is
are
correct.
right. No, I
Yeah,
mean,
yeah, correct. Yeah,
so
that is
then
correct. Yeah, that is correct. But he said this. That's why I am saying that in the
Okay.
previous session you can go. I think
Yes.
timestamp is 2 hours 12 minutes something.
actually, what happening? Closure.
I think it is about zero vector.
Associativity is somewhat an extension to closure with respect to addition. But you cannot call a space a vector space unless and until it has a 0 vector. If it has a 0 vector, then it also must have inverse, right? So inverse was the option.
No, actually, there is no discussion about it. All 8 condition has to satisfy that. There is no discussion about it. But the 3, he said,
but
some
when
3
you
condition.
But what is your view? Because in the exam, it will be a problem otherwise.
You cannot say
it's contradiction.
If two things add and we get a we get a real. Suppose if a plus b is real, a plus b plus c is also real. A plus b
How
plus c is
is this
extension
to
to a
be
plus b.
dealt in the exam? I mean,
But you cannot call a space a vector space unless and until it has an inverse. First of all, we have to check whether it has a 0 at all or not. If it does not have a 0, then it is not not a vector space. So try to prioritize the options.
True.
But actually, no.
Same time,
the condition is given.
Her doubt is also valid that all 8 condition is valid.
Okay, because it is the mandatory thing to do that, na?
Yes, sir. Yes.
sir, can you please verify this with
I have to ask 2-3
the
questions.
exam, because otherwise unnecessary will be losing on marks.
No. So if such thing will happen, right? You can raise your hand, and if such thing happen, there is nothing. If like nothing in the sense, if such, if there is
then we
an
can
ambiguous
raise it in
question,
the
you will
discussion forum, right? Like,
if there is an ambiguous, you can raise your hand, and it will clarify it. It will never like that.
And I don't think, sir, that this type of question will be in the quiz.
It is
that
here.
will create any ambiguity.
It will be not like, it will never happen like if there is ambiguous and if you are losing your one, it will never happen.
Mock is
kindly
still
discuss
a
about the
type
rank.
of
I
an
have two doubts,
assignment.
sir. There.
Mock
It's
is
already
still a
10,
type
15
of assignment, so that's why I think that we have got this sort of question.
Okay, but yeah, let me see that. The video the
Sir, are you discuss dimensions of matrix?
Sir, revision session for math and Python are merged. Please make it a distinct time.
Okay. Actually, the Python and maths are matching at the same time, I think. No? Python or math and stat, I think. Something like that. Okay, I will check it. Okay.
It's Python and maths at the same time.
Sir, kindly discuss the rank of the matrix, the rank of the vector space. Sir. I have two doubts in that, sir.
Okay. So I will check with the team this one. Okay. Actually, here, see, for us who knows prioritizing the, like, if there is no inverse, then it will never form a vector space. Associativity
second condition
usually
is
follow,
close
like,
extension to first one.
say the primary thing, primary thing is needed closer and inverse thing. Associativity is secondary, but okay, in the video is given. So actually, for that we have to follow. Okay, I will discuss with the team. Actually,
Sir, it's nowhere mentioned that we have to follow this order only.
Yeah, that's correct.
Yeah.
Okay. Okay, I will check and you update it. This one.
Otherwise, 3 options also no problem.
Sir, in activity question 4.3, sir.
Okay.
Question number 9 and 10. Sir, how could the rank be greater than the vector space, sir? Suppose we are discussing R3. How could the rank of matrix be 6? Sir, 4.3, question number 9 and 10.
4.3.
Yes, sir. Activity question 4.3. Question number 9 and 10.
Yes.
Sir, if you look at the answer, the rank is 6. It's a 3x3 matrix. Maximum non. Sir, suppose if we are.
It is not rank, dimension.
So, sir, when we talk about vector space, rank and dimension are the same thing, right?
Okay.
And we are solving homogeneous system of equations, a sort of homogeneous system of equations. How could a rank be 6, sir?
Actually, you have to check you have to find the basis of it, this vector space. No? And
The
then
basis cannot be, sir, a 3x3 matrix. How could a vector space with matrix? I don't understand this question. I'm confused.
No, a vector is, see, for this matrix, for this vector space, 3 cross 3, where, sorry, A belongs to 3M, 3 cross 3 over R, where A equal to A transpose. So what is the basis of this vector space? Can you tell me? Anyone can tell what is the basis of this vector space?
Sir,
okay, what is the basis of this vector space? 3 cross 3 over R. This is a vector space with the usual addition and scalar multiplication as in matrix. So what is
it
the
would
vector?
Contain nine elements at least.
9 elements. Okay. So
let's take for example 1 to 9. 1, 2, 3, 4.
Identity matrix.
Or 1, 1, 1.
Let us take the nine matrices. It would
9 element.
Yes, sir.
Actually, see, you have 9 entries independently. You can enter.
Yes, sir.
Sir, what is the concept of free variables, independent variables?
We can solve complete this, please. After that, we can go to the next.
Let's finish this one. Okay. So actually, see, if you want to see, this is a general matrix of order 3 cross 3. This is an element of this matrix, this vector space. This is a vector of this vector space. So see, these entries are independent. All are independent. You can give any real number to all of this.
Yes, sir.
So if you want to
I can write I can write a general basis for this. There would be 9 elements in that set. In general basis.
Actually, if there is a basis, it contains 9 vectors.
Yes. Yes, sir.
So how this is happening? How we are calculating that?
So suppose first one we are taking 1 0 0 0 0 0 0 0 0.
Okay.
So basically, for every if
Every
like in
element,
every
there is a 3
every
cross 3
element
matrix.
will have at only one. The rest will be 0.
Yes, sir.
Actually, if you collect the vectors like this 1 0 0 0 0 0 0 0 0, this is a vector of M cross 3 3.
Yes,
Another
yes.
vector is 0 1 0 0
Yes.
0 0.
Like this, we would get 9.
Like if you collect, it will be like this 0 0 1 till here will come. So if you collect these vectors, linear combination of this vector will generate this particular.
Yes, yes, sir. Agreed.
If you remove any one of vector from this, it will never generate this exactly. It will not give this matrix.
Yes.
It will not give this.
Agreed, sir. Till this point, I am
It
agreed.
means this is a general matrix. This is a kind of any general vector of this M3 cross 3. For that, we needed 9 vectors. Like this, 9 vectors.
Yes, sir.
So, and if you check that these vectors are actually linearly independent.
They are linearly independent.
In that case, this is a basis and this is dimension is. If you count those number, it will give 9. Now here is the case. This is the transpose of it. If you write a general matrix of this vector space, what will be? A11, A12, A13. Suppose you wrote
then
A is
A12,
equal to A transpose means
yes, sir.
it
Then
will
it would
be
be A12.
It will be like this.
Yes,
Yes, sir.
A
let it be A23, sir.
A2, A23.
A23.
Okay, okay, sir.
Something if you will give A33 or whatever numbers you will give. So if you see that this is the transpose of. If you take the transpose, both will be the same.
Yes, sir.
So now see how many entries you can independently give. Wait, this one, this one, this one. This is the same. This is the same. This one, and this one. Otherwise, if you give this entry some value here, it will automatically come here also.
Yes, sir. It would be either be upper triangular or lower triangular.
Sorry, upper triangle or lower?
Yes, sir. Because sorry.
Sir, what
not
happened
upper
when
triangle. Not upper triangle.
symmetric?
It is symmetric.
Means to say if you want to write the linear combination with some vector standard kind of thing, or maybe one always used to write like 1 1. So what will happen? You will write like this 1 0 0 0. So if 1 is here, okay, this will come this one. Okay, the next vector will be 0 1 0. So you assumed as A12 is 1. So A12 will also come here. So this will be 1 here. Because here is A12 and rest all are okay, fine, 0, assuming to be 0. Then other vector is A13, let's assume A13 is 1, okay, and rest all are 0. So this is 1 and 1 3 is here also. So it will be 0 0 0, 1 here will come, this one. Similarly, if you check for A1, A2, 2 to 3, the 3 vectors will come. Sorry, 6 vector will come.
Okay, okay, sir. Now I got it, sir.
Right? 6 vector will come.
Right.
If you take the linear combination of these 3, this is a general matrix, then it will give. If you eliminate any vector from this set, it will never give this general vector, this general matrix. So that means this is spanning. Actually, this is spanning this whole vector space. This span of this one is this whole vector space, this A transpose kind of. And actually, if you will check, these are the linearly independent. The process how we will check these are linearly independent. Anyone can tell? If you want to check these are linearly independent.
Sir, I mean A11 plus A12 plus A13 equal to 0. Then we take any one of the element to the right hand side.
No. The simple thing is the best thing is checking a linearly independent is let's take this is 0 0 0 0 0 0 0 plus b time vector plus c time this one n equal to 0, and form the system of linear equation and try to find the values of a, b and c. If you got the value a, b, c all are 0, then it is linearly independent. This is the basic basic definition of linearly independent, right? This is the basic definition.
Sir, and you said that to form the linearly independent, we need 6 elements. Also, sir, why not 9?
No, for this one we needed. No? For this one we
Actually,
needed.
A is equal to A transpose. The condition is given.
The condition is for this is A is equal to A transpose also.
Sir, but then, like, why not 9 elements and only 6?
Because you see that no, for A11 okay, for A12, A12 is also here because of A transpose is happening. If here it should be for, if you are not taking transpose, then it will be 2 1, not A1 1 2. It will be 2 1, but we are taking the transpose because A is equal to A transpose means general matrix. What will be the general matrix for this one? If here is this one, it will come to here also. When you take the transpose, it will be the same. No.
Acha, okay. Okay, sir.
Because of this transpose is happening, only the 6 terms are coming. Because see, if you are taking here 1 3, so if you take the transpose, means we want transpose are same, so means 1 3 should also here come. So if you take 1 here, then 1 will also come here.
Oh yes, I think now it's very clear. Yes, sir. Yes. Yeah.
What to do when it is A is equal to minus of A transpose?
Yes, that is also my doubt.
A equal to minus, still it will be the same.
But here the answer is given 3.
Sir, how come 3? How could 3 be?
I don't know. You have to check. For that, you have to then, okay, you have to check. I just said, okay, what is that?
I put 6, but got wrong answer.
A equal to minus A transpose. What is the answer here? 3. So, okay, you have to check. So, what is happening? So, do that, na? Why you are worrying? Do that and then verify, okay?
Sir, can we take a vague example and do using that example?
Let's take a general matrix. Okay, A11, A12, A13. Okay, and see, if you are confusing or it is difficult to write like this, so just write properly. Write matrix A21, A22, A23, A31, A32, A33. This is your matrix. Now take the transpose of it. It will be A11, A12, A13, A21, A22, A23, A31, A32, A33. It says it should be equal to, means minus term put here, minus means minus, 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 here all are minus. And it says these two are equal. Just compare what it means that. Means A equal to minus A11 and A12 is equal to minus A21 and A13 is equal to minus A31. Means if you write a proper matrix, it will come like this. A11, A12, A13. Okay, so just 1 minute. Okay. Okay, so then after here we need to compare.
For these type of matrices, the diagonal elements are always 0. That's why we have only 3 elements.
That's why it's happening. Actually, when you compare here also, then A1, A22 is equal to minus A2. Oh. So when it will possible, when it will be 0. So diagonals are going to 0. Only this one, and this one. Yeah, actually that's why I just wrote. If you are facing difficulty, just write like this equation. And
Sir, I
compare.
didn't get how it is 0. Can you just explain?
Yeah, actually what is happening, A equal to A minus A transpose. Means what is this is equal to minus, means what you are getting. You just compare, na? These two are equal. So this is equal to this. When it possible? Only for the 0. Right? A11 equal to minus A1. What it mean that? 2A11 is equal to 0 implies A11 is equal to 0. Right?
Okay.
Means similarly for this one will come, this one will come.
So
diagonal
there
are,
will be only 6 elements in this set, right?
So
Again.
no, not
And
say.
out of these 6,
only
3 are equal.
Three
Because it is
will
transpose.
come, and
Yeah,
That's why
right.
3.
Yeah, right.
That's why it's coming.
Correct.
So here we get at 2 1 equals to minus at 2 1. That will be also.
No. So A12 is equal to minus A21 means it is coming as independently they are coming. What it means that if A is equal to, okay, what is happening here? If your this is matrix, then it will be A12 is equal to minus A21 minus A12, and here it will be A13 minus A13. It will become like this. And similarly, if you compare, see, you have to shift with the thing, like, see, you have this one, you got this, just shift and you got that. Okay, diagonals are 0, and what is happening entries here, just compare those and put the values, means count the how many is independent number you are able to keep. That's all. Like how many entries you are independently you are able to keep. Clear?
Yes, sir, got it.
No, still I made a mistake. That's why I made a mistake here.
Sir, actually, in this minus A transpose, I can explain, sir.
Actually,
in this minus A transpose, all the diagonal elements are 0, right? And in the upper triangular matrix is equal to the lower triangular matrix.
In antisymmetry matrix, I saw in antisymmetry matrix, but here I saw diagonal are not 0.
No, actually, for this diagonals are going to 0, and A12, and A21 is going to retain as minus A12. So you can replace 21 with the minus A12. Similarly, rest all are you can replace, and actually you will see that these and this and this one are going to be the independently you can give the numbers, and rest all are like this is here, so minus of that is coming. This is here, so minus of this is coming. This is here, so minus of this is coming. What it means that if you write the matrix, if you are write the basis, it will become like this: 0, 1, 0, 0, 0, 0. Oh, no, here will be minus 1 and 0, 0, 0. This is a base. This will be a vector of a basis. The next one is 0, 0, 1, 0, 0, 0, and minus 1, 0, 0. This will be another, and next one is 0, 0, 0, 0. Okay, 0, 0, 0, 1, 0, minus 1, 0. These three vectors will only survive in the basis. If you check that, if you take transpose of it, it will be the same, will give. Getting no?
Okay, got it.
What I am doing, just write the proper matrix and compare and solve the equation and put the values here and get the basis as and right.
Got it, sir. Now I got it.
Okay.
Sir, is there anything more to be discussed, or can we leave, sir?
Sir, could you go back to the workings 1 second? Hello, sir. Could you go for the A is equal to A transpose? I didn't get how, I mean, if this was A transpose, why is the first column A11, A12, A13?
This one. No, this one. We were here or here.
Yeah, this one. When we transpose it, why is this first column the same as the row?
So we are taking the transpose of it. Na? See, we assumed A equal to the proper A11, A12, A13, whatever the proper matrix.
Yes.
Now, transpose of it will come as written as column wise. Okay. Now, but this minus should become. So, okay, we substituted also because we have condition here also minus. We are considering those matrices which are satisfying this condition. in this condition, A equal to minus A transpose. So okay, we have general matrix. Okay, we did this like this and say these two are equal. So okay, just substitute. Okay, these two are equal.
No, but this should read, this particular matrix should read, if I look at the first row, it should read A11, A21, and A31, isn't it?
A31, a transpose of it will come, right? Na? You have A11, A12, A13, A2,
Right.
A22, A2.
Yes, yes.
What will be the transpose of it? A11, A12, A13 here will come, na?
Yes, and then A21, A22, A23.
So that's the I wrote here, na? It will come like this.
No, you've written A12.
Where is the table?
A is equal to A transpose.
A equal to A transpose. So
no, shouldn't the second column read A21, A22, A23? Isn't that supposed to be?
Second will come A21,
A21.
A2, A2.
Yeah, so you've written 1, 2. That's why I'm completely confused. Okay.
Where is that?
Then A31, A3. Okay. So
no, it is proper. Here is A21.
okay, I think I'm looking at the wrong one. I'm looking at the one below. And the one below is the one I'm looking at, just below A.
The simple thing is, maybe I wrote wrong, but the simple thing is transpose, that's all.
So if it's transpose, then the diagonal elements would be 0.
Because of this minus is happening. Then because this is
okay, and otherwise?
Otherwise, not equal to 0. Not necessary, right?
So the basis would remain the same.
The basis will be then differently. Just now we discussed this one.
I'm sorry, I didn't understand it. That's why I was asking you. The basis would be same or different?
Then basis will be different, right? From the previous one.
And the dimension?
Basis is different. The dimension also will be different. Na?
Okay, I'll go through it again and maybe.
You can do one thing. You can rewatch the video.
I'll rewatch it. I was watching throughout, but then maybe I didn't understand. Actually, I got stuck when you wrote the transpose, so I could not make that sense, and that's where I got stuck. And then the rest I didn't understand. Okay, I'll just go watch it, and maybe I'll ask in the next session.
Yeah. Just simple. There is nothing. There is no tough thing. There is just need to precisely write. If you write precisely one by one in your copy, you will get the idea. That's all. Because we are doing nothing. Just transpose we are taking. Minus we are substituting. That's all. There is no. If you write precisely, you will get. Oh, this is happening. Oh, this is happening. That's all.
Okay. Thank you.
I have a question. Maybe it will be easy if we go to solve with this 4 not graded question 9.
Okay.
Question 9. It is just not solving the 9th problem itself, but if we see that there is clearly a definition of vector space as x, y, z such that 2x plus y is equal to 2x plus 3y is equal to 0 and y plus 5z is equal to 0. If only one of the equations is given, can we really solve this?
If one equation is given, there is no issue. If 2 equation is given, also there is no issue. Why?
How can I? Because let's say only the first part is defined. 2x plus 3y is equal to 0. There is no mention of z. Then how do I actually solve this?
Okay. It's better to write here. Maybe any of you will have confusion. Okay. Please tell me what is that? V equal to?
V is equal to xyz element such that 2x plus 3y is equal to 0. And it's a subset of R3, let's say. I mean, the next part.
Next equation is what is that?
Y plus 5z is equal to 0.
5z is equal to 0.
Subset of R3 is what it is written as, but
subset of R3.
Yeah. If the second equation or the first equation, one of the equations is eliminated, can I really solve this? Because I don't have any definition of z anymore.
Actually, see, my question is, what are the terms will come here?
3, X, Y, and Z.
No. The term in the sense vectors. Means, can you give a particular vector which will come here? Any particular vector?
Means, sorry, you want numerical value?
I want a real number of x.
Okay.
By any real vector.
Any real number. Okay. -3 and 2. -3, -3, 2.
-3, 2.
No. Only I'm giving you the x and y values. -3 and 2 because I have only
-3 and 2.
2. Yeah.
And z, what will you come then z?
That is where I'm stuck actually.
So that means you have to solve these two equations, then find the value of z, right? You have to give z something.
You can give one.
Means you have a system of linear equation like this. Means what is here? Z is 0 times z equal to 0. If you are missing here, 0 times x is equal to 0.
Correct.
So you have a system of linear equation. So vectors will come which will satisfy these two equations. Will come here. Right? So solve this equation and solve the equation, then you will get a vector, then you will get a vectors.
So the matrix is going to be 2, 3, 0 and 0, 1, 5.
2, 3, 0. And so actually this system has infinitely many solutions. Easily can solve. See, there is no mean to writing like matrix. Y is equal to -5z and x is equal to -3y by 2 means -3 by 2 here if you solve this one.
Yeah.
It will be then -5 means 5z will come here. So it will be -15 by 2z. So this system has infinitely many solutions. If you give the value z, if you take z is equal to t, then x is equal to -15 by 2 t and y is equal to -5t and z is equal to t. What are the vectors will come here? You will give the t values 1, 0, whatever will come. You can write x and y and z.
Yeah.
So vectors you can easily write. So what it mean that you can if you want to write a particular vector, just give t is equal to 1. So it will be 1 and the second is -5 and third one is -15 by 2. This is a vector. Similarly, other vector will come. Means other vectors are. So what it mean that? Okay, so you got idea how to write the t or whatever?
Yes. So basically, z is independent and x and y are dependent on z.
On z. So now what is the next question here? Which of the following is the form of basis of t? What is happening then? How can you conclude what will be the basis or what is the dimension of this vector space? Actually, it is answering itself now.
Dimension is 2, isn't it? Because 2, 3, 0 and 0, 1, 5 will be the rank itself.
No. Okay, first, what is the basis? Okay, dimension, before going to dimension, comes to the basis. What is the basis of this vector space?
Number of free variables. Basis is number of free variables.
Number of free variable for this system elimination is for the system of linear equation is happening. Okay. We are consistent with this. So my question is, how do you are finding this basis, or can you give a basis of this vector space or basis any basis?
The basis is just what you just gave, isn't it? -15 by 2t, 5t, -5t and t. So that's only one basis. That means that is the rank of the matrix, or rather dimension and rank.
Actually, that is happening. Actually, when you write as like here, -15 by 2t and -5t and t. So actually, you can write t as
belonging to R.
T as like this.
Yeah.
So what is happening? Only one vector is here, no?
Yep.
If you give t is equal to 1, means minus 15 by 2, minus 5 and 1.
Correct.
And if you write the linear combination, means if you want to generate all other vectors, just write as here t is happening. If you multiply t, means same thing is happening. This is says a linear combination of this vector.
Correct.
So actually, this is the only vector which generate can whole vector space. Means it
Yes.
be a spanning vector, you can say, or
right.
This vector is a spanning set is only this one.
So that will be the dimension of the
now what
space.
will be the dimension then? If this is a span, means a single vector is always linearly independent, you know. Any single vector is always a linearly independent vector.
Correct.
So
that is the basis itself.
And independent. So it is going to a basis.
Yeah.
Now the dimension is only one vector contain the basis, so dimension.
Yeah. So it's 1.
Clear? No?
Yeah, it's clear. So if I actually construct a matrix 2, 3, 0 and 0, 1, 5, through that also I should be able to get only 1, right?
In that also you will get that is the like we directly solve, otherwise we are going to solve with the matrix, you can solve.
Sir, Gaussian elimination method can be solve this question, sir.
Can you try it, because you just mentioned Gaussian elimination.
However you want to solve, we can solve it. Because
Sir, one doubt.
Sir, Gauss elimination, there is a problem. 2, 3, 0 and 0, 0, 1, 5.
No. We can reduce into RRE. We can reduce it into RRE, and the column which have leading entry is basis of this vector space, and the number of leading entry column is the dimension of this vector space. I think sir have explicitly told in his lecture. We can use also Gaussian elimination method using a vector as a column of matrix.
This is where I'm having my doubt. I'm trying to do this, but I'm still ending up with 2 rows of the matrix, and that means the rank is 2. But just as sir has pointed out, with 1 itself I can do the entire thing. So which one is it?
So yeah, actually what is happening, see, this is okay, you are thinking as a matrix and changing as saying to be the 2, but we want vectors here, not we are considering this system, we are considering vectors here.
Oh,
the vectors will come here, whatever the vector will come here, it will satisfy both equations simultaneously.
Yes sir, yes sir.
As here is happening.
And sir, we can create matrix, sir. 2, 1, 2, 2, 0, 3, 3, 3, 1, 0, 5. Like 2 into 3, 2 into 3, 2 row, 3 column matrix. We can create from this system of linear equations, sir.
See, you can solve, but see, whatever you are saying, okay, fine. However you are solving, no matter. We want vectors here which satisfying these equations. However you are solving, no matter. You cannot conclude with, okay, this matrix, your coefficient matrix have rank 2, then how you are concluding? See, basis is concerned with the vectors, not the here. We want vectors here which satisfy these equations.
Okay.
Vectors will decide the basis, vector will decide the thing, dimension. Not this system. System says system is like a criteria. Means criteria in the sense from R3 there are so many vectors in R3. From there you are choosing vectors which satisfying these 2 conditions and putting into here.
Hello, sir.
Okay. The case where if z is not defined, let's say 2x plus 3y is equal to 0 is the only thing that is given. I cannot do anything with it. Is that correct? Because z is not defined anymore, but I have 3 variables.
Actually, it is happening because you have 3 things here: x, y, and z.
Yeah.
But you have only 2 condition is given. Means you have to be add here z. Then it will be right.
then I just have to add Z over there. But
add means 0 times Z means
0 times Z, but Z will always be 0 in that case. It's x comma y comma 0.
0. Z is actually working, if you remove this part, Z or maybe include also, Z working as an independent.
Z is working as independent. Okay. So any value of Z is still going to satisfy 2x plus 3y. That is.
But x and y are dependent on Z.
Each other. No, in this one, they are not dependent, isn't it? If 2x plus 3y is equal to 0 is the only equation given.
For this equation, yeah. So y and Z are working as independent. Because
y and Z are working as independent.
Independent. Because Z is okay 0 times, there is no mean of Z. But yeah, 2x can be written as minus 3y.
2x can be written as minus 3y and Z is any value. So there are two independent variables. That's what you mean to say. Okay. Okay.
Hello, sir.
Actually, sir, actually, I was trying to solve one determinant part where I need to find out the number of non-zeros in the rows. But sir, actually, I end up with only one 0 rows. But Sarah has explained 2 0 rows. Could you please help me out how to make it out?
You're always voice is breaking. I'm not still. What is? Whenever you are asking, your voice is started breaking.
Sir, is it audible now?
Yeah, now it's clear. Okay.
Sir, one matrix, could you please write 1 minus 2 0 4?
Okay.
1 minus 2 0 4.
1
the first row.
1 minus 2 0
4.
4 also.
Yes.
Okay.
This is 4 by 4 matrix.
Okay.
3 1 1 0.
Okay.
Minus 1 minus 5 minus 1 8.
Minus 1 minus 5.
Yes.
So what you want for this?
Sir, actually here I need to find out number of 0 rows or non-zero rows. I want to find out number of non-zero rows. But actually I end up with only one, like 3 non-zero, but Sarah has explained only 2 non-zero I should get.
Maybe your calculation may wrong. Just properly calculate and count the number of non-zero rows. That's why you are. You want to solve this, and I am going to succeed. I am very bad also in numerical, so I don't know. Maybe I make a mistake. But yeah, the thing is, you need to properly calculate and then count the non-zero rows.
Sir, actually I tried many times, so maybe I thought maybe my process is wrong or something. I just wanted to verify. Could you please help me out?
Okay.
Because I tried many times and I could not find out the root cause.
So I will say again, try and then do that. What I will say.
Okay. Okay, sir.
Hello, sir.
Yeah.
Sir, if a single vector in a vector space, then it is linearly independent and dimension is 1. If there is 2 vector in a vector space and it is linearly independent, then dimension is 2.
Okay.
And if
okay, continue.
If in a vector space there are 2 vector and it is not linearly, it is linearly dependent, then what is the conclusion?
In part 2.
See, first thing is zero vector space. Zero vector space is actually contains 0 element. If you are in R2, this is a vector space, and with respect to usual addition and scalar multiplication, and see, in this there is no independent vector. All are dependent, and that's why this basis is 0 only. Dimension of this vector space is 0.
Sir,
there
for
is no
three variable, there is only 2 equation in that case.
3 variables.
2 equation. X, Y, Z, 3 variables are there and 2 equations are there. Then always the values are dependent on another.
Possibly.
How can we calculate the dimension in that case?
Dimension, like here, I didn't get, like, see, what is you, I think you have confused with the maybe confused with this one, maybe because of this, because it is two equation, as you are here saying, right? This one is very similar to this, because this
I want
contains
to know the general rule of calculating the dimension.
okay. No, actually, this depends on condition. It's totally depend on condition. It is not necessarily like, suppose I am making like this, x plus 2y plus z is equal to 0. Again, I am writing like this. More equation, I am writing the same equation. Okay, still it will work only the one side. It's depend on the situation how you are dealing. It's not necessarily there is no general rule for this. I think it's depend on the situation. If you have this situation, solve this and get the answer, I think. Okay.
Hello, sir. I have doubt.
Okay.
Activity, first chart, activity 4.1, question number 10, option 3.
Activity, which activity?
4.1.
Question number
10, option 3.
3. Okay. This one. What is doubt?
Yes. Sir, why not option 3 is correct? I got the answer. Option 4 is correct. So why not option 3 is correct?
No, option 3 is correct, no, because it is independent.
Okay. Okay, sir. I think I saw wrong.
Okay. Nice.
Okay, 4.2.
What is 4.2 again? Okay.
4.2, question number 3, option 3.
Question number 3, option number 3. Okay. This one.
Yes, sir. Why, yes, sir? This is correct, sir. When we are eliminating one vectors, what is the main first line? Small b belongs to capital B. Sir, what is the meaning of this line?
Okay, this means that, see, this says you are taking a vector v from a vector space, but no, from a set. The set is v minus s1. What it means that I'm writing here. Writing here. Okay. This the expression is v, capital V and s1. Okay.
Yes.
This is the expression. It means that you are taking a vector from the vector space which is not in s1.
Okay.
Okay. You are taking a vector from V which is not in s1. You are subtracting s1 from V, right? This is the main.
Okay, sir.
So it is not from the s1, so surely it will become as a linearly independent. If s1 is independent, then V is not from the s1, means it will come as a independent.
It means s1 is not present in V, right?
S1 is not present in this expression. Not present in V, no, in this expression.
Yeah, in this expression, that particular set in which the small v is present, right? That v,
in that
small v is element of bigger V, in which s1 is not present.
It's not present, yeah.
Okay, sir. Question 10, same activity.
Okay.
Sir, I have a doubt in question number 4. This one only. Can I ask?
In this,
okay.
The same.
Yeah.
Question number 4.
4. Yeah, sir. So I have solved this question. I just want to ask, what are all the necessary conditions that we need to check that whether this third option, the union one, will satisfy or not? Because in some cases it is possible that the union of two vector space will be present in a subspace, right?
It can.
And yeah, it may. Yeah, and in some cases may not be present, right? Yeah. So what all we need to check that whether we will verify that whether it is present or not.
So that means you have to check that those three conditions for the subspace.
Yes, sir. So is it okay to think that whether all the element of B1 and B2 is in R2 or not?
Sorry.
No, for subspace you need to check.
Or we need to check all the three conditions of subspace.
Yes.
See,
that
Yes.
general rule is that if you are taking intersection, there that goes to be subspace, but the union may not be. In
Yes,
some cases, it may be also,
Yes,
but
sir.
you have to always check these three conditions.
Yes, sir.
for-
And yeah, that I understood. But sir, I am just asking that what all condition we need to check to verify this, that whether it is present or not. What are all the necessary condition we need to check?
All three conditions, whatever
In this case, like I know that for a vector space we need to check all three condition, whether zero vector is present or not, and if there is two vector v1 and v2, then v1 plus v2 is present in that vector space or not, and if there is c in that any real number and v is in any vector space, then cv is present in that vector space or not, right? These are all the three conditions. But in this case, what I understood is, if I will check that v1 is already in the vector space, right? And v2 is already in the vector space, right? So the union of both will be in the vector space or not. If we will check that all element of v1 and all element of v2, and the 0, 0 is present in the vector space or not, that will be enough to check whether the union.
Still, because it may not close. It may not close.
Yeah, then we need to check all those three conditions, right?
Anyhow, you have to check all three conditions.
All three conditions. It is not enough to check only this union one, right?
It may not, because sometimes
Yeah.
it is not
Correct. That's why it is always not true, right? But intersection one is true because it is common one, right?
It is always.
Yeah, and I think what is when it is be possible will be when v2 or v1 will be the element of any of the one, right? Like v2 will be the element of v1, like it is a subset of v1 will be the subset of v2, or v2 will be the subset of v1. Then it is possible that the union of both will be the subspace of R, right? Yeah, that's what. Thank you so much, sir, for clarifying this.
Question number 6, sir.
Okay.
In the question, okay, that is already discussed.
What is out here? No, it is not discussed.
So, sir, I cannot get the correct answer. That's why, sir.
This is the same thing which I just now discussed for the solve with assignment question. Totally similar to, where is that? Full similar thing. Where is that? This one. In that we checked for the two equations. Here is only one equation.
Yes.
This is totally same. There is no change. Here is only one equation is given. So means which vector will come? Like we got here only the one vector, right? Here is only one vector was coming. But in that you will see that one vector will come also, and another three vector will maybe come. Where is that question? Actually, three independent ways. So three vector will come.
When we put z equals to or y equals to w, then it
you
will
have
be.
To see, if you solve this equation, it will be x is equal to minus z plus y plus w. Means y, z, w work as a independently, and only x can be written as in those form.
Yes.
So means it will get, see, each time you can may give z is equal to 1 and rest y and w is equal to 0. The second thing is give y is equal to 1 and z and 0, z and w 0. Means you are getting different vectors. Only the x is dependent. For here we are getting only one vector, but for that one we are getting three vectors. Three vector means three independent vectors. No.
Okay.
Very similar. Just very similar. Just very similar to this. Just think
Okay.
that.
In this question, I need to assume z or x, y, z from anyone.
Any one of the rest
w.
of.
Okay.
Sir, hello, sir. Sir, actually, I have always confused for considering dependent variable and independent variable, sir, in a row row reduced echelon form. Sir have said that like column which have leading entry is dependent variable, dependent variable, and column which have not leading entry is
not leading entry, that those are in work as a
independent. Why, sir? Why it is happening?
Oh, you can think as a definition also, or I have very properly discussed in the lecture also. See, I can discuss here also, but see, you can think as a definition also. Otherwise, the simple thing is in the same equation, whatever is this one, this equation, x plus y plus z. Okay, suppose you have a matrix like this, 0, 1, 1, 1, 1. This you have a this matrix. So, okay, which one is going to be independent? Leading entry is this one, no? And rest all are like rest all are not leading entry. These are not leading entry. This is the leading entry. So whatever the variable will come here work as a dependent and rest all are work as a independent. No?
Independent.
So what it means that let's say this is x, y, z, w, and t. This will come. So if you write this equation, it will become like this. Something will come and then you will write equation. So it will be suppose like this is happening. X when x something. Let's say this is alpha, beta, gamma, delta. Something is there. So means alpha is going to be 0, 0 times alpha. Okay. Beta y plus gamma w gamma z plus delta w. Something will come. Means what it means that you can write y as a in this form. Something when z w t in this form. That's why y work as a dependent. See that these are freely you can give and y as a dependent working on this. That's why you can see. No, I didn't clear.
The value of y is dependent on the variables.
So what is happening when you form this system of linear, whatever the matrix is given, when you try to transform that in the system of linear equation, y work as a rest all, y is a dependent on rest all the variables. That's why y is working as here directly if you are inferring from here.
So if we say x plus y plus z is equal to w, w is dependent on x, y, and z is what we are saying, right?
No, x plus y plus if it is like this, if you suppose you got from this matrix you got this one, so means y is equal to minus z minus w minus t.
Right.
So y is dependent on z w t. That's the also from here you can say or from here you can say.
So ZWT will be independent and Y will be dependent. Is that correct way actually put in it?
Y is dependent and ZWT is work as an independent, and X is also work as an independent also. But in the context of that's why if you assume with at a definition, that's all enough. See, there are so many things as here is looking, but I am trying to show you with this kind of. Otherwise, if you assume with the definition, that's also enough. Like this leading will come as a dependent and rest all work as a independent.
Okay.
So it's too much time. I don't know. Many
So,
of you got answer.
Yeah, it's already.
I have.
Thank you very much. Thank you. It's already 11, past 11 actually.
So we can close the session now.
Thank you very much. Thank you. Good night.
I have doubts, sir. Good
night.
Sorry.
I have doubts, sir. Also doubt.
What is your doubt? Okay.
Question number 10.
Same here.
Option 2, 3.
This one.
Yes.
So what is this is the totally definition. Any maximal spanning set must be a basis. Any minimal linearly independent is
Must
be.
minimal. Okay.
It is
Why
a
this?
I think so.
Okay, sir. Move on for 4.3.
How many you have? See, you have to watch video then.
Sir, okay, sir. Question number 2, option number 4. That type of question I saw in practice assignment. So, sir, in yes, in this question, I cannot get the answer. Option number 3, option number 4, dimensions.
This one.
D, yes, dimensions. Dimension of these vectors.
So you have to check, is that independent or independent? You have already told.
Yes, I know that is dependent. That is a dependent variables, but I can't get the dimensions.
No, if it is dependent, then you have to do something more, right? You have to do something more. Like, what is the process? If you check that they are dependent, check that these two are dependent or not. Check these two are dependent or not, or check these two are all three are dependent. If all are coming as a dependent, means only one vector going to be independent and rest all are on the dependent. Means only one vector will be the independently and rest all are the combination of the simple. The process is
when you get dependent variable, so then sir I can't get it.
If you see these three vectors are dependent, so check that is these two are dependent to each other, is these two are dependent to each other, is these two are dependent to each other.
Okay, sir. Then sir, when you get the dependent variable, dependent vectors, then what should I do?
Just eliminate that. If you got a one dependent, just remove that, and now check rest two. It's independent. If that is also going to eliminate that. That is the process.
Okay, how do you get the independent variables? Those vectors are present. Those are independent. Then dimension will be how much?
So whatever the remain independently will come. You can
vectors.
That is the then you
okay.
Can.
Okay, sir. Got it, sir.
Okay. So the session.
okay, sir. That is too late.
Okay, thank you so much.
Thanks, sir. Yes, sir. You have put a lot of efforts.
Thank you, sir. Good night.